So today is going to give a speech and tell us more about what is happening at Ton.live and how we could really learn more about it and give us some much other features. Thank you very much, Mr. Alex, for joining us today. And over to you, please.
Thank you very much. First of all, it's a pleasure and an honor to be here. Thank you for inviting, and we're delighted to be partners of the Africa Blockchain Institute Hackathon as Ton Labs and as Freeton. And I want to start out by saying that that I want to congratulate everybody who is participating in the hackathon, because I think you guys are on a very noble mission. Technology is something that can really help, nations to transcend essentially generations of, of development, like it happened in China 15, 20 years ago when, China went from a relatively, it was relatively behind on the technology side compared to the United States and Western Europe and some of the other countries, and then it made a massive jump on adoption of electronic payments and digital wallets and e-commerce, etc., etc. So I think blockchain is something that can do similar thing in Africa, that Africa can kind of leapfrog, and transcend a couple of generations of technology and emerge as one of the technology leaders in decentralized IT applications, as we call it, decentralized backend. So I think you guys are on a very noble mission, also because blockchain can help solve some of the issues that Africa as a continent is facing today. Things like property and land rights, to make sure that it's transparent and trustful. Things like voting platforms, things like traceability to fight corruption, traceability in food supply to make sure that food and medical supplies are supplied in a transparent manner and are not fake, which is obviously very important. So I want to wish you to continue the journey on a very noble mission. As you probably might know from the announcements, Freeton is a partner of Africa Blockchain Institute, and Freeton Africa particularly, our community of about 200 people growing very quickly. It's also proud to be a partner in that. And I would like to make a short introduction of what Freeton is, and also happy to answer any questions. I know you guys later are going to have also our technical team talking to you in about 1 hour and 45 minutes. So you'll get a more technical dive into Freeton, and I'll do more of a general, strategic introduction. So being in the blockchain space, I guess we all know that there are two main issues on the way of blockchain adoption. One is performance and scalability. Blockchain platforms used to be and still tend to be very slow. On things like speed, latency, throughput, blockchain is significantly behind some of the other centralized IT applications like AWS and any other one. And the second one is adoption by developers and adoption by users. And that's a more complex thing. It's more linked to, things like having modern developer tools, modern user interface and user experience that normal people get used to. And Freeton was born as a way to address those two big, barriers on the way of adoption of Freeton. It was envisioned and initially designed by the Telegram Messenger team, famous Durov brothers who established the Telegram Messenger. They envisioned integration of Ton, Telegram Open Network blockchain, into Telegram Messenger to enable currently more than 500 million users of Telegram to use the blockchain and to be able to use the wallet and make peer-to-peer transactions and pay with the cryptocurrency of Ton, of the Telegram Open Network blockchain within the Telegram Messenger. So in order to enable that for 500 million people, it had to be very productive, the protocol, very scalable, very fast as well, and with a low latency. So that's how they designed it. They did research for over a year and a half of the best protocols at that time, like Cardano, Tezos, Tendermint, Ledger Cosmos, Polkadot in the early makings, etc., and came up with what we call kind of multi-threaded architecture for the blockchain. And I don't want to steal from our CTO, who is going to talk about that again in a couple of hours. So I'll just mention that it's basically a way for the blockchain to shard, infinitely, to able to process millions of transactions per second, and to be able for millions of users to interact with the blockchain, which is something that is not possible today with the current platforms. And that's what they designed, that's what they envisioned, and essentially delivered. As you might know, unfortunately, they were not able to launch because Security and Exchange Commission thought that the way they conducted their token sale for $1.7 billion was illegal, and they sued Telegram, and Telegram had to cancel that project. Luckily, that's where our company with a broader community stepped in. And our company is called Ton.live, and Ton.live was envisioned to solve the second issue of the blockchain. So the first one, remember, is scalability and throughput and productivity. And the second one is adoption by developers and users. So Ton.live was created in 2018, almost 3 years ago now, with a mission to write open source operating system called Ton OS, Ton operating system, to complement what Telegram was developing as a raw protocol with 2 additional layers. One, let's call it middleware for simplification. And again, our CTO will talk about that, with a whole bunch of developer tools to make development on Freeton easy, fast, and cheap, and available also in different programming languages, so that people could develop on Freeton in the languages they prefer, for example, C or C++ or Solidity or something else. And then the user level as well. So the user interface and user experience would be something that people get used to, with modern applications, with Facebook, with WhatsApp, and with Telegram, and the other applications out there, but being decentralized and enjoying the benefits of the blockchain. So with that mission, Ton.live was created almost 3 years ago, and we were writing Ton OS on parallel with Telegram issued alpha version of their Ton blockchain. Our company basically was helping to design, to debug the network, to do documentation for the network. And for that, we had to basically reverse engineer the whole code of Ton, of Telegram network blockchain, to be able to do that. And then, probably most importantly, we developed second implementation of the node on the Rust language. Originally, Ton was developed in C++, and now we have a second implementation on Rust, which is also open source now. And that helps to accelerate debugging. It helps stability of the network, because you have 2 implementations of the node. If something happens in C++, Rust nodes will pick it up, or the other way around. So it massively had massive stability to the network. And as we were doing that, again, developing second implementation of the node, reverse engineering of the code, and documentation and debugging, we basically knew Ton protocol intimately well. So when Telegram lost to SEC, we were in a good position to step in as a core developer of the network, replacing Telegram, and to launch the network. And that's what we did. Freeton was launched on May 7 by a decentralized community of 23 initial members, some very reputable companies which are professional validators in the proof of stake space. The companies like Everstake, P2P.org, Certus, Chorus, Doki Capital, and some other famous name in the space launched the protocol on May 7. And there are kind of 4 big things about Freeton, why we're all very excited, and why I hope Africa Blockchain Institute and some of the other proud partners like, Armand from GBA was talking yesterday. We're very active members of GBA as well, GBA Association, and very close partners. So there are 4 things. The first one I already mentioned. It's the superior vertically integrated technology stack. Again, with the best on the market throughput, speed, and scalability, and lowest latency, as well as a whole bunch of developer tools, which again, our CTO and 2 developers will talk about, so I don't want to steal their speech. The second big thing about Ton is it's the second protocol since Bitcoin who did what we call a fair launch and did not do any token sales. There was no ICO, there was no token sales. And Ton crystals, which are tokens of Ton network, are never going to be sold. They're going to be given away for free in exchange for contribution to the network by validators, by developers, by active community members, and by partners. I'll talk about that shortly. And a good example would be we have a chapter of Ton in Africa. And I don't know if John is here, but John is one of the leaders of that. He'll be talking today as well, I think. And those guys got allocation of tokens because they're doing a lot of exciting things in Africa. They're helping ABI to prepare this beautiful hackathon. They're developing a few applications. They're building a website for Ton Africa, etc., etc. So that kind of contribution would be rewarded. And again, it's the second protocol that did not do any token sales, which we think is important because regulators are going to be increasing their pressure on the blockchain and cryptocurrencies. And it's important to stay very clean. And that's what Ton is doing. And Ton Labs, being now core developer of the network, just like Satoshi Nakamoto did 11 years ago, kept only 5% of the network and 95%, just again like Satoshi did with Bitcoin, and 95% of the network would be given away for free to validators, developers, and partners, and community leaders, obviously. The third thing is that I would mention is the partnership model. 85% of tokens would be given away for partners with existing use cases to bring those use cases into Ton and to bring their user base, existing or new. And that's our way to address the problem of Telegram stepping out of the project and the need to get, a massive user base, hundreds of millions of users to help adoption of Ton blockchain and all of the beautiful applications that are going to be developed on Ton, and hopefully, by the way, by you guys as well, as part of that hackathon and also going forward. So 85% of tokens, which is 4.25 billion of tokens, would be given away. The token currently is traded at about 40 cents. So that's $1.7 billion worth of tokens to give away to partners, again, to populate that with the use cases. And there were already 23 partners already came to the platform and are integrating currently with Ton. There are some simple ones, like in 170 countries, including some of the African ones. You can top up your mobile phone with Ton crystals. There is a Ton shop where you can buy Ton merchandise. And there are some more, some more strategic use cases, like there is a case by a company called Human Ventures, which is traceability in donations and charity. And I hope they bring that use case into Africa as well. They're also issuing one of the first tokens on top of Ton. So, and many more, 23 use cases in total, with a whole bunch of use cases piling up. And I know that Ton Africa community is actually developing 3 use cases to come around March time. So that will be first contribution to the network. And I hope you guys do as well. And maybe the last thing I'll mention, and then I'll let you ask questions, is Ton is truly decentralized by intent, by design, and by execution. There is no legal entity. There is no central authority. Ton does not belong to anybody. It's just a network. The tokens are in so-called givers. There are 3 givers: validator, developer, and referral giver. And basically initial members, 23 members, vote for distribution of tokens when partners come to the platform or contests are being realized on the platform. If you go to Ton, forum.freeton.org, the forum of Ton, you'll see a whole bunch of contests and partnership proposals. So once those reach critical mass of positive comments, community initial members would vote for distribution of tokens to those partners. And very soon, all token holders, people who have more than 10 tokens, will be able to vote on contests and partnerships. So it's a little bit like Wikipedia, that again, there is, developers, validators, and users are contributing to the platform and being rewarded with tokens. So there are no grants, there is no central leadership. It's a very decentralized one. And the way to do that is, I mentioned already the global governance, 23 initial members. The way we're doing this is through so-called sub-governances, local governances, and they are geographical. There are 5 of them now. China, Mexico, France, South Korea, and proudly Africa, actually being the 4th one, which I think is amazing. And there are 12 functional ones, like developer experience, DevOps, DeFi, esports, etc., etc. And there are more coming up, both functional and geographical. So it's like a snowball, that goes down, engaging more and more snow. Freeton is rolling down, engaging more and more developers, partners, and users. And I believe that's the only way to build an exciting, scalable platform that belongs to the whole community, not just one company or one foundation, one organization. So that's why we're all very excited about Freeton. And again, congratulations, guys, on making it to the hackathon, and looking forward to some exciting developments. Happy to answer any questions.
Thank you very much, Alex, for this great presentation. It's very wonderful working with Freeton thus far. And we hope to have much more broader collaboration. And I think there's some questions coming through already through the chat. You can kindly check on them and give a response to them.
Sure. I see the question from Joseph, is the governance of Freeton on-chain or off-chain? The short answer is it's on-chain. All of the decisions are transparent and made on-chain. If you look at, so I mentioned already the forum, which is a public forum to discuss contest and partnership proposals. So once again, there is a critical mass of positive comments. They go into the vote, and all voting happens transparently on gov like governance, gov.freeton.org. You can see all historical contests and all partnership proposals where jury voted, where initial members voted for that contest or partnership to happen. And then in contest jury, which we have 40 jury, and it's growing very quickly, 40 jury members are voting on the particular submissions in the contest. And again, it's all transparent. All partnership proposals and contests can be seen. What was it, who voted, who are the winners, and how many tokens it got. What value exactly does the use case have to the whole network? Use cases, developers coming into using Freeton. If I understand the question correctly, it's like what value can developers bring to the Freeton? There is a whole bunch of proven use cases on blockchain and still to be proven. Everything from identity management to medical records on the blockchain, all the traceability and supply chain things. I mentioned land and property ownership, voting on the blockchain. There are a whole bunch of use cases that can be realized, and I think now that blockchain platforms like Freeton operate with the same or similar, I should say, scalability, throughput, and latency like the centralized platforms, more and more centralized cases can migrate to decentralized backends, enjoying the benefits of blockchain, which were spoken a lot yesterday. I won't repeat, like trust, traceability, mutability, etc. So it can be basically anything. How different is Freeton with Ethereum? Very different. The only similarities that I would mention is decentralization. I think Freeton, Ethereum is very decentralized, and Freeton is aspiring to be decentralized. It already is on the validator level. There are about 400 validators on the network, but there more has to happen on the community. And then Ethereum has elements of centralization, like there is Ethereum Foundation, there is consensus. It's pretty centralized development, so Freeton is meant and designed as more decentralized. But the big difference is, of course, on two things. One is Ethereum is still on proof of work, and Freeton is proof of stake. like some of the other more recent protocols like Polkadot, Near, Cardano. It's a proof of stake platform, and I don't want to steal again from our developers who are going to talk to you in an hour and a half. And maybe the last difference I would mention is performance. Ethereum blocks are being formed, in about 17 seconds. It's kind of long. For most use cases, it's quite long. So if you go to the browser of Freeton, Ton.live, blocks on Freeton are formed in about 0.2 seconds, which is sufficient for most applications. For gaming, for fintech, 0.2 seconds is not noticeable. And transactional cost, of course. As we all know, on Ethereum, it can be anything from $5 to $200 at peaks. And on Freeton, it's now like less than 0.1 cents, and it keeps going down as there is more adoption. Those are main differences. Does this mean that Ton.Labs is in it for the long term, or most use cases might require years to reach full usability? I think there are two questions here. One is Ton.Labs is definitely, as you can see by the name, Ton.Labs is definitely with Freeton for a very long term. The company carries the name, and I think we'll keep being core developer of the network, contributing to the protocol. Ton.Labs would not do use cases except some complex ones. Like we're doing a use case now with the worldchess.com, with the world's with FIDE partner in chess, to bring Freeton blockchain as a unified backend for chess in the world. So that's a highly complex use case, more than 1 million lines of code. And Ton.Labs is helping to do that use case. But otherwise, we would count on the community to deliver, hundreds and thousands of use cases. And we would help as we can by doing things like Freeton Academy. We're now doing, and again, Freeton Africa is very engaged, Freeton Academy, and working on the developer tools to make it easier. And then on the question, years to reach full usability, yes, of course. Blockchain will start eating market share from centralized IT, and it will take 5, 7, 10 years before it will become massive, and before decentralized backend solutions will grab substantial share. But I'm totally confident they will. And there'll be a significant part, not 1%, not 3%, but significant percentage of IT solutions will be on backend. So again, you guys are in the right place and at the right time to benefit from that adoption. How can I exchange Freeton and get cash? There are a few listings. There are 5 or 6 listings of Freeton. It's not my domain, so I'm not following that deeply. There are a lot of peer-to-peer and quite famous exchanges like HitBTC, Bitcoin.com. I know some of the bigger ones are considering listing, some of the big global exchanges. There are a few peer-to-peer exchange platforms. And there is actually partners that we have called Merkle Tree Capital, who has 4 exchanges or wallets in Africa. And I don't know on the timing, but I'm pretty sure that in February they will do the listing. So there is even African platforms. But again, if you just Google, if you go to CoinMarketCap or CoinGecko and see what exchanges support Freeton, you'll see all of them. I think I answered the questions in the chat. Happy to answer more questions or people from the Zoom. Unless Kayode, it's time to move on.
All right, thank you very much. I think
it's my pleasure.
Yeah, thank you very much. I think if you have more other questions, we can able to direct them down to you. Probably now, I guess you're on the Discord channel. They could be able to send you some messages there as well, and they can also message you on the Telegram group page as well. So in case they have any.
Sure. If you join Freeton Africa chat and Telegram, I'm in there. Please tag me directly. I'm there as Alexander Filatov. So Freeton Africa, if you search in Telegram.
Okay.
Thank you very much. It's a pleasure.
Thank you very much. It's a pleasure to have you today. I hope to look forward to having you much other time.
Absolutely. My pleasure. Thank you.
Yes. So right about now, I'd like to welcome, I can't pronounce his name, but Abhishek. I don't know, can you unmute yourself?
It's
And
Abhishek Bhattacharya, but Abhishek is good. I think that's enough.
okay,
Thanks.
thank you very much. Apologies. So Abhishek is a blockchain expert and professional. He has been in the space for a longer time and with a lot of interesting experience about blockchain technology in general. And is here today to share us some important information, especially on the curriculum that I shared with you earlier on what is blockchain, and some other important components as well for we to have a background knowledge on what it is you are doing. Then it's going to be followed up by the developer team from the free Ton lab, and then we have a very sync understanding of how blockchain works together. Can able to use this knowledge to pass through for the hackathon program starting tomorrow. So, Mr. Abhishek, it's over to you, and we can start.
Thank you so much, Mr. Kayode. It's a pleasure to be here, to be speaking to this audience today. And I could see the hackathon going up, had started, and I wish everyone all the best. And I believe that what we are going to learn today is going to be exciting for you all. Pretty much the lecture is about the core of blockchain, or blockchain core concepts. And by the end of it, by the next 1.5 hours, I believe that you should be able to understand blockchain at a much better level because we are going to target such topics. And we are also going to take a look at certain use cases from across the world which have happened on blockchain using blockchain technology, and they have real customers, and are also working with one is also working with government, which is my own use case, and government of India, of course. So I hope that this would also give you an idea of what exactly to do when you're planning for this hackathon as well, or even after that, if you're going into blockchain, this is going to be very, very valuable, I believe. So give me 1 minute. Allow me to share the screen, please. Just a second. Yes, I think. Yeah, please, Mr. Kayode, could you please confirm once you're able to see my screen?
Yes, we can see your screen.
Perfect. And I hope it is changing as well. Great. All right. Thank you so much. So much so that I let me just place my Zoom window in a manner so that I can view the chats. So if you have any questions, any doubts, please do reach out in the chat, and I'll make sure that I answer them. And yes, perfect. All right. Welcome everyone to this lecture. It is a pleasure to be giving this lecture out with in conjunction with Africa Blockchain Institute for the Campus Blockchain Hackathon. And we, as you can see, are entrusted by so many good partners. Yeah, I hope the slide changed for you as well. So this today, what we plan on covering is basically the core of blockchain technology. We are a bit pressed for time. We are starting a bit late. But however, we are going to make sure that as much as the core concepts we can cover, and we might move a bit fast, but in any case, in any time, if you believe that I'm speaking very fast, or I'm moving at a big speed, please do unmute and let me know, Mr. Kayode, if you see any specific chat from regarding the speed of the lecture, please do let me know. Then I'll immediately make sure that I reduce it. Perfect. So as a roundup of what we are going to learn today, first of all, we'll take a look at an introduction basically to overall decentralization, DLT kind of technologies, and particularly to blockchain, how blockchain came into effect, why it was needed, why were people looking for decentralization. That is something we're going to take a look at. We will take a close look at the types of blockchain that we have, this may sound like a very easy topic, but when we are differentiating between public, private, and consortium blockchains, it becomes very important for us to understand that what kind of blockchain to choose based on the kind of use case that we are trying to develop. That is important. Public blockchains, we all know, Bitcoin, Ethereum, we all want to work on them. But then again, the entire world in real life, when we are building real world situations, use cases, we are not 90% of the times it would happen that a public blockchain would not be very beneficial or not be the choice that you would want to take up. So that is important. Apart from that, we have, so we'll continue with basic of public blockchains. We'll just take a look at an overview concepts of nodes, network, incentive mechanisms. We'll try to understand what kind of incentive mechanisms are usually there, but we won't go very deep into this, not technical, but definitely why these exist and what kind of incentive do they provide majorly. And also I put with that, I've made sure that we also take a look at two. If you're looking at two types of incentive mechanisms, we also take a look at two kind of attacks that nodes can commit against these incentive mechanisms. At the end, towards the end, we will take a look at three use cases I have prepared. Those three, very short, not long, we won't discuss at a lot of detail, but those three use cases, again, as I said, are real world implementations. And I believe that that is what will, please stay put, that is what will help you understand that what exactly to build when you are planning to use blockchain technology to build something. Perfect. All right, so that is what my purpose is for the next 1.5 hours. We have all of that. And I hope that this lecture actually pushes you to the front of the understanding that's needed to loop up to win those tons up for grabs in this hackathon, right? It would be lovely to see that happen. As a basic introduction to set the stage of why I might be a good person to even talk to you about blockchain. I'm the co-founder of a startup called Whrrl. We are into we are an agri fintech blockchain, and we are India's largest such platform on blockchain, and also the first on blockchain. And we are working with the Indian state governments. So that gives us that gives me to talk about a great use case today. Where you can see that India has been very much dicey about the future of cryptocurrencies. But then again, we are talking about blockchain use cases, and India or any such government has definitely invited it with open arms. So that is one thing we can take a look at. I have experience with. Apart from that, I was previously at a company called PolicyBazaar.com, which is an Indian unicorn insurance aggregator. Have experience in that as well. I'm an author and a speaker, regularly do that. Have authored 2 books, and 2 are coming up with Springer just in 2021. And apart from that, I have similar lectures I've given to more than 4,000 faculty and PhDs and students just in 2020 itself. So this is a passion that I follow. So I hope that you'll be able to see that passion. I'll be able to impart that knowledge across in these 1.5 hours. Perfect. That was a brief intro. Excuse me. So let's take a look at what today's basically the entire session looks like. We'll take a look at why blockchain. We'll understand the concepts. I've already told you that, and also why decentralization was essential. We'll learn about consensus mechanisms as well, in addition to what I said earlier, and use cases. I think this is something I've already covered. And ultimately, this lecture is not going to be very technical. If I have any questions, if I see any questions in the chat which require me to go technical and we still have time, that is something I would love, really love to go a bit technical as well. Otherwise, this lecture is going to enables you to move past the barrier of entering blockchain concepts, and then you can take up more advanced courses or more advanced studies in the same segment. Great. Let's start with the topics then. So as I have planned this lecture, we are going to first set the stage by understanding why was this everything needed. It has been what, a decade or 11 years since when Bitcoin really made blockchain technology very popular. That was not the first time that blockchain saw an implementation. It was back in 90s when the technology behind blockchain came into existence, and it is evident in papers written by Dr. Scott Stornetta, who is regarded as a father of the blockchain. So it is since then, but it is almost 10 years, 11 years that Bitcoin came, since 2009. And in the recent past, 3 years, 3.5, 4 years, you have seen the Bitcoin go crazy. And with that, blockchain's implementation and use of blockchain technology across various sectors, this has created a lot of hype. So we will first take a look at why did this even come into being, the need for decentralization, right? So let's start the example. Let's start the discussion with an example of a bank. So currently, so what is decentralization? I'm sure that if you've been into blockchain, then some of you might be having an idea of why this came into being. But for the people who are not very much into this, I would be glad to start here. So let us say that I use any particular bank. You have a bank account. I have a bank account. Even if we are in the same country or abroad, maybe we use SWIFT mechanism to transfer money. In any case, if I send you say $100, my bank would write it in its own ledger, which is centralized, by the way. It will write in its own ledger that Abhishek gave $100 to Mr. Kayode. What happens is that so this is updated by my bank. This is updated by Mr. Kayode's bank as well. In case we both have the same bank, then it is the only one bank that is writing it in their ledger. That's fine. That is how it has been happening since decades now, since forever, since when banking systems have existed, right? But what happens if the bank, what the bank does is essentially, tomorrow morning you wake up and your bank, which you trust so much. So trust is the keyword. Please make sure that you remember this. Trust is the keyword around which all of this is centered. So you trust your bank so much, but tomorrow morning you wake up and you see that your account does not reflect, my account does not reflect the $100 that I sent to Mr. Kayode. What happened is that my bank overnight decided to collude, say with Mr. Kayode or say with Mr. Kayode's bank, and remove the ledger that there was any transaction that ever happened regarding the $100, right? So that's basically where trust becomes an important factor. You cannot do anything about that because that was the only ledger where this $100 transaction was written. When that happens, I have no other way than to believe that I have lost those $100. But the problem is that I had to lay trust in a system which is centralized in nature. That is what centralization is. And anything that opposes this particular system is what decentralization is. That's essentially all of it. So to be honest, this is why. So currently, many people I've taught this, they come with the example that they come with the doubt that yeah, but we have so good banks in the world, and then we have so good companies such as Google or Facebook or maybe banks like JP Morgan and so on. They will never do this thing, right? They will never go bad. They will never go rogue. But that is the whole problem. What if they do? What people do not understand, the people who do not understand that someday something like this can happen, they are the ones who are not going for decentralization. To understand decentralization, you have to understand that what you are trusting today can be nowhere to be seen tomorrow morning when you wake up. That is the whole problem. And if you're talking about great brands, they might never falsify information. What about everything else that you trust in? It is not just big banks that you trust in. You trust your data in the hands of many such companies, even small startups, right? So for example, we are a 2-year-old startup, even though we are India's largest such blockchain network, but we are just 2 years old. But if they place a trust on us and tomorrow we just want to go bad and anything can happen, right? The founders decide that, okay, let's delete the user data that we have. What happens then? That is the whole point of decentralization. And that is why we ourselves are a blockchain company. And every partner that we have banks as partners, we have governments as partners. We make sure that the entire network runs in a very decentralized fashion, so that tomorrow it does not happen that my startup went bad and the entire economy fell. That is what the example is. That is why decentralization is needed. I believe that that gives you a good understanding of why decentralization was needed. It might look like not a big issue today, But just think about all the organizations and all the people and all the companies that you lay your data in the hands of. Any one of them can go rogue tomorrow, and that is where the problem would occur. So just to go over them, the grave issues of a centralized world, you do not have the control over your data. That is the point. You have to have control over your own data. That is what decentralization really fosters. Also, as we just discussed, you cannot trust a single entity, however big they are, because many a times even big entities commit such frauds which no one is aware of, and everyone is at a loss at the end of the day. And these frauds are uncovered years later. So just imagine how many people, how many businesses, how many partners, how many governments, all of them lost money to the fraud over all those years. And when it is finally discovered, there is nothing you can do. Right? I see someone unmute. Is there a question, or am I going fast? Anything? Mr. Kayode, is it all fine? Is the voice good?
Yeah, it is good. Please go on. It's going fine.
Perfect. Thank you so much. All right. I have the chat open. If you have anything, anyone, please write to me. And also, just continuing quickly.
What's that?
Yes, Claire. You have a question? Oh, I think by mistake you may have. Okay, perfect. So again, going ahead quickly. So one very important point. Make sure that if you're jumping into the use cases of blockchain, make sure that you are implementing blockchain solutions in an implementation where these kinds of problems are there, such as collusion between two companies, corruption, frauds, scams, scandals. All of these things either of these things are happening in that particular segment. That is where you'll face the most benefit. If you're just sharing maybe social network content and you want to put that on blockchain, or you want to make it decentralized, there is not a lot of use case that might be covering there, unless you have such use case, which you can define, which I might not know. But if there is especially, that is why financial platforms, fintech platforms in India, abroad, everywhere I've seen, in Africa as well, in US, everywhere I've seen that fintech platforms have been the ones who have benefited the most from these concepts. So hence, because they face most collusion, frauds, corruption, scandals, all of that. So make sure that you have a very direct use case where decentralization can help. Otherwise, it might be a wastage of efforts. We'll see that very soon. So as we were discussing, so is the answer to all of this a blockchain, any DLT technology, right? We'll take a look at that. So that is the question that we pose, and that is the question that the blockchain industry has been trying to answer since about the last quite a few years, right? This is the question that we are trying to answer. So before I go to one core concept of blockchain, and to take a look at what public blockchains look like and what are the types of blockchain, I would love to share a couple of myths that the world has till currently regarding blockchain technologies, right? So I see a chat. Okay, so hi Lawson, I see that. Can we have the document of your presentation in French? Because I'm a francophone, so it's good to see that you're joining. You're French. I'm sorry, I am not French, but I don't know if Mr. Kayode would or Africa Blockchain Institute would be able to provide that. But let's see. We'll have a talk maybe later, maybe on WhatsApp or email. I'm not sure. Spanish is something that I know, so that would have helped. I could have tried, but not French. Not good at French. All right. So perfect. So let's go ahead and take a look at the two myths that I wanted to share quickly. First of all, everyone, believe me, when I say everyone, I am talking about even faculty and PhDs of great institutes, India and abroad, people from Bulgaria, New Zealand, United States, Australia. These are all the countries where I've taught people. Everyone, when I say, is that believes that cryptocurrency and blockchain are one and the same thing. There are such a great number of people that I know who believe that blockchain and cryptocurrency are one and the same thing. That is the case. That is why I usually give these slides before that is why I usually give these slides, this particular slide, before I start with any real content, any deep tech content. Blockchain is not cryptocurrency. Cryptocurrency is one use case of blockchain. If you're talking about Bitcoin, if you're talking about Ethereum, Ether is again a good use case of blockchain. It has a great platform for smart contracts, but it is also a currency. The currency is an implementation of blockchain technology. It's not the whole of it. So we have to make sure that we understand this part. So going ahead, that blockchain is not all about crypto. That is why so many governments who have banned cryptocurrencies are very much in it for the blockchain technology. They are very much attracted to the characteristics of blockchain technology, and they want to implement blockchain technology even in the public domain systems. So make sure you know that. Second one is that blockchain can become everything. A lot of people. So myths, these myths I have not taken from the internet, believe me. These myths I have, you can say I have understood that what kind of myths my students actually had, and 4,000, 5,000 of them just in 1 year. And that too just in the COVID months of 10, 11 months, right? And these are the myths that I came up with because I saw that everyone is having these kinds of doubts in their mind. So blockchain can become everything is what people think. People believe that if they have a blockchain network, whatever data they are getting from the blockchain network back, that is going to be truthful, right? And they believe that every use case can be fulfilled by blockchain. So for example, someone who wanted to build a to-do app, I've listed here, I've written it here, you can see on the screen that someone wanted to build a to-do app, and he came to me and said, I want to build a to-do app on the blockchain. But why? If apart from learning, if that is something you're trying to do to learn Solidity, to learn smart contracts, to learn blockchain technologies, best case. If you want to make a business out of this idea, why would you want to put a to-do app, a to-do functionality, a to-do list on blockchain? Blockchain has very specific characteristics. I think I should have put a slide on that. I'm sorry if I missed. Blockchain has characteristics of being the data being immutable. Whichever it goes on blockchain, it is immutable. You cannot touch it. You cannot change it. Blockchain gives you the characteristic of finality, of provenance. These are very deep technical words, but the blockchain is able to give you, it is able to tell you where finality is where the data is heading. What is the actual data? Provenance tells you that where the data originated, what is the entire shape of the data, how did the data come into existence, who uploaded, because you know that none of it changed, right? So immutability is that one characteristic which helps. Security is again a characteristic of blockchain networks. So all of these characteristics you have to map out, which I said, I think 3-4 slides back. You have to map out your characteristics with blockchain, with your use cases that you need to solve. If your application or your web app or Android app or anything does not need blockchain's characteristics, I do not believe that you need to implement blockchain there. Just go ahead with a database. Just go ahead with an RDBMS system, relational database. Because if you don't do that, then blockchain is going to be an overhead, because blockchain is not very easy to use. We all know that for sure. The concepts are pretty different. They're easy. Well, now once I know blockchain concepts, it's so easy for me to teach it to people. And then people who understand, they take it in happily, right? But when you're new to blockchain, it becomes a bit of a complex behavior, complex nature of these concepts. And implementation of these concepts becomes more and so difficult in your everyday apps when you're building an Android app or a web app, especially, because then you have to do a MetaMask integration. You have to make the customer's browser talk to your network, which is running on the blockchain. So all of this is a bit complicated. And eventually what happens is people don't use your product. So this will be an overhead. So make sure that your use cases are very much mapped. Please do not build a to-do app on blockchain and make it a business. Because you're not going to create a fraud on a to-do app, right? You're not going to scam people in a to-do app. You're not going to, you don't need the data to not edit in future, right? So these things you have to make sure. We are using blockchain to provide loans to farmers in our country. Never believed that a segment like farmers would be using a blockchain system. And it's quite possible that our farmer customers don't even know that what the loan they're getting on is a blockchain technology. Many people in my country have not used blockchain technology yet, but our farmers have used blockchain technology. So that is something that is one use case that is getting a lot of attraction in India itself, right? So, but then again, it's because our blockchain solves the fraud problem in loans. It's just not there to, be on the blockchain and, ride the hype game. It is there to solve a particular problem. That is one point I wanted to share. So that is another myth. Please don't think that blockchain can be implemented everywhere. right? Okay, going ahead, I see another chat. Let me take a look. Abhishek, where we get this presentation document. Hi, Santigi. I hope I pronounced your name correctly. I will be very happy to share this presentation on maybe WhatsApp or email with Mr. Kayode or you guys, or you can even reach out to me and take this presentation. Either way works. I'm happy to give out any content that I have, along with the knowledge that I'm trying to give in this lecture, right? Perfect, perfect. Claire has asked one question. So one request, Claire, listen, one request that if you just don't direct message me, rather if you send it to everyone, what will happen is that everyone would get to know that what is it that I am answering, and people would have more idea. So Claire has asked that what are the core characteristics of blockchain? So as I just said, I'll quickly go through it once again. I'm sorry. I'll just quickly go through it once again. The core concepts of blockchain are these only. It protects the data from being manipulated. It does not allow the blockchain systems. Once a data goes into on a blockchain network, we will take a look. I have a couple of slides of how the blockchain works essentially, and we'll take a look that how the behavior is. And apart from that, it is, as I said, it provides finality, it provides provenance. Again, I'll just repeat in a sentence. Finality is, what the final shape of the blockchain data is. Provenance shows the history of that particular piece of data. You can go further and read about it. Blockchain provides provenance of data, shows you where the data came from, what the data looked like, and you know that the data did not change. Security is something that that blockchain provides. Another core characteristic is transparency, big one. Nothing is as transparent as a blockchain network. You know that every transaction on the Ethereum blockchain platform, you can take a look and you can see. Anonymous, big factor. Things are transparent, but they are anonymous. That is the best part of blockchain, because you are essentially, if you're doing a transaction, you're essentially behind a 30 or 40 character address, for a 40 character long address. What happens is that people know which two addresses did a transaction, but they have no idea who were the two people in real life behind those public keys or behind those addresses. Trying to keep it non-technical, but these are the encrypted addresses, wallet addresses that you get, which I guess many of you must have already tried out till now. Create a wallet, do a transaction, and so on, right? If time persists, I would be happy to make it live, go on a blockchain explorer and show you a couple of blocks, how it's made, right? All right, I'll quickly go ahead. Yes. Okay, so we have dealt with the myths. We have taken it out of the way. I would really request all, I see 20 people here. I would request all of you to make sure that you keep these myths in your mind. Not cryptocurrency and not everything, right? Blockchain cannot be both these things, right? So out of everything, why blockchain? Here is where we take a look at. So in addition, Claire, to what I just explained, this is the slide I was talking about, where we take a look at how blockchain has the kinds of characteristics that we were discussing. So now I'll quickly go through this because mostly I have explained it. First of all, a blockchain or a decentralized network has no central point of failure. What is a central point of failure? Just like what we discussed at the beginning. JP Morgan Bank taking care of my entire transaction ledger, it goes rogue, it goes down, its systems get hit. Eventually, I lose access to my money. I lose access to my transactions, right? So that is what does not happen in a central point of failure, right? So blockchain has many nodes, multiple nodes in a blockchain network, which eventually make sure that the data is in a very distributed nature. Hence, if any of the nodes go down for any reason, what happens is that other nodes can serve up the same kind of information, just like distributed systems in general. And on the other hand, if one node goes bad, one node goes malign, they want to do something bad, what happens is that other nodes make sure that things are in place, and they can recognize that this is the particular node whose ledger does not match, and that something bad has been done by that particular node. So that is what central point of failure means. Trust. Please note this sentence very carefully. This is real from real experience, not from Google. Trust comes before technology in business. You believe that businesses are running on the technological platform that we are providing. We do that as well. When we are doing loans for farmers, we have an entire suite of platforms we have given to banks, warehouses, quality managers, farmers, traders. Everyone has a platform. But ultimately, what comes into effect, what comes as a use is the trust that we've been able to build. However, because trust comes before technology in business, the need of centralization to trust that particular party has been there since forever. If that is something that blockchain systems can replace, That is where actual real life industrial use cases are found, just like ours. These we are talking about Indian banks. They have been very secure in their nature. They have been very strict about their methods, but even they are accepting a blockchain network like ours because of the kind of trust we are able to build on a decentralized network. It's not just the trust in us, because we are again a centralized entity, a 2-year-old startup which can maybe shut down tomorrow, which can go bad tomorrow, do something bad tomorrow. But then again, the platform and the technology that we've built, that is completely on blockchain. It's decentralized. And when we are selling it to the banks, we make them understand that you're not buying us, you're not buying trust from us. You're buying trust in that decentralized, trustless system, effectively. That is what comes here. So trust comes before technology in business. Again, as I said, immutable and hack proof. See, scam and scandals always happen, and your money just, and the data and transactions and everything just goes poof. It's all over for you, as we discussed in an initial example. In the case of blockchain, that never happens. In fact, it is one of the strongest technologies that we know exists. Also, when we will be taking, just in a couple of slides, as I can see, we'll be taking a look at the different types of blockchain networks. This is the criteria that creates a big difference between two different kinds of blockchains, which is public and private. Right. So we'll take a look at that. Right. This, I have spared one entire slide on this, because always make sure you remember, blockchain networks, especially the public blockchain networks, they have all the data out in the open. They are public, but again, they are anonymous. Before blockchain came into existence, this combination, public but anonymous, this kind of combination I did not hear for any kind of technology, right? But with blockchain, we can see that everyone can see. Even we can see the first transaction that was done by Satoshi Nakamoto on the Bitcoin blockchain. We know that that particular transaction was done by Satoshi Nakamoto. That's why we can relate the transaction with the creator. But every other transaction, millions of the transactions that have happened on the Bitcoin network or Ethereum network or any such public blockchain networks, we all know that they have happened. We can see how much Ether was transferred, how much Bitcoins were transferred. But then again, we have no clue that who is behind that particular address. Public, but anonymous. That's all. Perfect. Any questions here? Because we are moving to another second section of our lecture. Any questions here? Would be happy to take. Please write in the chat. If not, I don't see any questions till now. If not, okay, no chat yet. So I'll move ahead. But in case you have any questions in between, please do write to me. Perfect. So what are the types of blockchain that we know? I wanted to cover this in a bit of detail, attacking certain concepts. So we have public blockchains. We all know examples, Bitcoin, Ethereum. So all these are examples of public blockchains. And essentially, any public blockchain is any blockchain where you have a blockchain explorer available for the use of the public. You can go to that blockchain explorer. If you haven't gone yet, you can try out the Bitcoin blockchain explorers, the Ethereum blockchain explorers, and you'll understand that what I'm talking about. If I have time at the end, I can do that as well for you on call live. So public blockchains are the ones which have their ledger completely open and all the transactions are visible on the network. Another characteristic of public blockchains is that you can join the network at your will. You can set up their own client on your particular computer, Mac, Windows, Linux, anything. And you can download the entire copy of the blockchain ledger that is there. And then you can start, as well as participate in the network. You can start mining transactions if you have that kind of compute. And also you can start, updating your ledger, and you can continue to go on like that. Those are public blockchain networks. Ledger is open, and also you can be a part of it without anyone's approval. Private, on the other hand, which is on the right side, private blockchains are very centralized, to be honest. They are not 100% decentralized. They are quite a lot centralized. But definitely they use blockchain technology, so they are in a very gray area. And what happens is that in private blockchains, you need permission to enter a particular blockchain network. Similarly, you need permission for a hybrid network as well. So these are the two networks where you need permission to enter the network. Additionally, what you have is when you're transferring data, there is one central authority which takes control of that, takes care of that entire blockchain network. That is why I'm saying that usually in this scenario, the blockchain network is a bit close to being centralized as opposed to being decentralized. So, and it's a direct connection between all the nodes. If there are 1, 2, 4, 5, whatever nodes are there, there is one ledger. The consensus mechanism is controlled by the single entity, and all of that happens in a public network, private network. When we combine both of these, we get a particular blockchain network, which is a consortium blockchain network, or a hybrid blockchain network, or a permissioned blockchain network. You can call this by either of the names. There are very wide difference sometimes people make. But at this level, if you're learning it for the first time, you can consider all of these to be kinds of hybrid networks, where you're just combining methods and functions and characteristics from two different public and private blockchains. Right? I have an explanation which we'll cover. So public blockchains, you can see that they completely eradicate the middleman. When you're doing an Ethereum transaction, or when you are participating in the Ethereum mining, there is just zero middleman. It completely eradicates that concept, and hence the rates, the fee that you pay for anything in real life. I'm not just talking about between blockchains, but the fee that you pay to intermediaries in real life to get a job done, that goes off from the chart. Also, they are, again, we have discussed it so many times today, that they are transactions and they are anonymous, but they are anonymous transactions. So this is something, but yeah, public, they are available on the ledger. One characteristic of public blockchains is that they are economically incentivized. What is that? Miners make sure that they take a look at, so they have an entire pool of transactions before they pick the transactions in the blockchain while mining. And they usually sort it based on the kind of transaction fee associated with every transaction. The more, the merrier, right? So for example, if you want your Bitcoin or Ethereum transaction to be pushed to the front of the queue, and you want many miners to pick them, TechnoSpark 3, I think you are trying to annotate something. Would you please not do that? All right, I have disabled annotation for others, but I don't know how to remove this. Okay, Mr. Kayode, is there something that we can do? I think this might create a bit of a problem.
Okay, what is that?
Okay, I think I have an option. Clear all drawings. Yeah, all done. Cool. No problem. Yeah, I think someone by mistake, did some scribbling on my blockchains, right? Okay. So I'll move ahead. Now I have disabled it, so not a problem. So where was I? Yes. So the what public blockchains have actually, sorry, the flow breaks. Okay. So miners are, when we talk about miners, they usually rank. So they have a pool of transactions, as I said, and that is why I was telling that when you're doing an Ethereum or a Bitcoin transaction, TechnoSpark 3, I think, is you're on unmute. If there's a question, you can post it in the chat, please, or else we can take it up later. So yeah, so that is how these blockchains work. If you pay more transaction fee per transaction, there is a high chance that the miners in these networks will pick up your transaction faster than they would any other transaction. So they are incentivized. So this is one of the incentivization mechanisms, right? Incentive mechanisms that we are anyways going to cover a couple of points more on this. But then again, this is what incentives are. The miners are incentivized in value. This is value incentivization. That I will mine more transactions which are higher value, which have higher transactions fee associated with them. Also, in public blockchains, the more number of nodes in that network, the merrier, again here as well. So the more number of nodes, the stronger and the more secure this particular blockchain becomes. Currently, Bitcoin network itself has, I think, 20,000 plus nodes all over the world. What happens is that, see, why are they secure? Let's try to understand that. When we are talking about a blockchain network, there is an attack. I'm going a bit technical, but I think we can digest it easily. Won't go into much of detail. There is an attack called the 51% attack, which says that if more than 51% of the nodes in a network go bad, go malign, that network can be hacked. But this is a theoretical concept. Why? That is why blockchains are practically unhackable, which I shared a couple of slides earlier, that it is hack proof. But theoretically, this attack exists, and this attack can only happen when the number of nodes are less. For example, if I have a 10 node network, 51% and above would mean 6 nodes out of 10. It is fairly easy, not very easy, but fairly easy to talk between those 6 nodes and collude and make sure that, they all 6 of them come together and do bad things. On the other hand, if you're talking about a network as large as Bitcoin, if you're on 20,000 full nodes running all across the world, 51% attack would mean 10,000 plus, 10,001 or so plus nodes would have to be bad. It is practically an impossible job for one node to go around the world talking to 10,001 different nodes and collude, and that to reach one financial benefit, which not even be benefit to a lot of people. So that is why this is so secure that 51% attack cannot happen to a network like Ethereum or Bitcoin, because they have grown so big. So the more the network grows, it becomes impossible, practically impossible to break that network. That's why people don't believe private networks are very secure, because then again, there's two parties transacting privately. It is almost similar to being centralized in nature. However, one demerit of public blockchains is that the transactions per second, the throughput, you can say, the transactions per second is a huge bottleneck. Can someone write in the chat if you know that how much time, I'll move ahead, maybe I can tell the answer later. Can someone tell how much time it takes a Bitcoin transaction to be successful? And also how much time it takes an Ethereum transaction to be successful? Please write in the chat. Let's see that if the class is interactive. And I'll move ahead. I'll continue to explain. We'll take this up later otherwise. Please write in the chat if you know, or maybe a guess. I see one chat. I need more answers. Okay, okay. I need more answers. Also for Ethereum, any idea for Ethereum? Even blind guesses would do. I see Mr. Alexander. Yeah, I heard you. I heard you at the beginning. Of course, can I expect the answer from you? So right, 10 minutes for Bitcoin, 17 seconds for Ethereum. These are pretty standard that we know. And so 15 to 19 seconds you can say for Ethereum. And but again, 15 to 19 seconds. You know what? I have one slide after some time which shows the difference between networks such as Bitcoin and Ethereum, and one network that we know so popular across the world, which is the Visa network. We'll take a look at the transaction per second throughput difference between these two networks, and then we'll discuss more about this maybe. I see more answers, but yeah. And Mr. Alexander writes that it's 0.2 seconds for free ton. So you have the answer there, and that is why all of that in the first slide that I showed. You have great opportunity to go for ton, right? So perfect. Perfect. So that is something. Please look into the chat if you haven't yet, everyone. Perfect. Thank you, Mr. Alexander. Thanks a lot. So yeah, so going ahead, let's take a look at, so transactions per second is a bottleneck in public blockchains. In private blockchains, that's not a problem. We have high throughput because, the mining does not have to happen in that fashion. Is the basic form of a blockchain, very limited participants, and within them the transactions per second is very high, and that is why it is similar to centralized systems. It allows high privacy of data because you do not share the data on a public ledger, but it is very less secure as it is usually controlled by a single entity. It again kind of comes back to that JP Morgan bank example, that we are running a private blockchain. It is as good as, almost not same, because it's blockchain technology at the end, but it's as good as using an RDBMS. So that is one concept I wanted to share. So be aware when you're working on private blockchains. I am personally also, I'm not very sure how beneficial private blockchains would be to you. So make sure that you are very sure about the use case you want to achieve using private blockchains. On the other hand, when we are talking about consortium blockchains, this is the best one that you should pay most attention to. Public blockchains, you already know. Bitcoin, Ethereum, so familiar. Consortium blockchains, I have seen personally that people are not very aware of, especially people who are not in the industry yet. Consortium blockchains are semi-decentralized. They are very much decentralized, to be honest. Also, they are very secure. They are comparatively way more secure than any other blockchain networks, and also they are very well suited for organizations that want to run certain use cases on the network, on the blockchain network, right? So if you take a look at a few of the characteristics, they definitely have the characteristics of a decentralized network, such as, again, immutable ledger, transparent only among the participants of the consortium network. It is not open to the public. That is how it differs from a public network. But also it is very close to a private network, but not a private network. That is where the value comes in. So for example, I can tell you that we are a consortium network, consortium blockchain. We use Quorum blockchain, which is built by JP Morgan, now given to now acquired by Consensus. We all know Consensus is behind Ethereum as well. Consensus's founder is behind Ethereum, Ethereum's founder as well. So good hands. And so that is a permissioned network. Do take a look, Quorum blockchain. So all these are examples of permission blockchains. And also they have a very good and important feature which we is very beneficial for us and similar use cases. When you have multiple stakeholders on a blockchain network, for example, you have banks, we have banks, we have warehouses, we have farmers, traders, we have then collateral managers. Every bank would not want that all of the transactions to be visible to any other bank on the network. So we have 5 banks on the network. Each bank will only want that their data should be visible to themselves and the warehouse that they're dealing with, right? And also the customer that they're dealing with, but not with any other bank, right? That is one feature that is not available on the public blockchains, which is what private blockchains brings to the table. They have, especially networks like technologies like Quorum, they have something called private transactions, where while doing the transaction, you can designate the particular node to whom the transaction is going to be visible. When that happens, only those 2 nodes, say for example, bank A and warehouse A, only those 2 nodes are the ones who are going to be able to take a look at that, what the transaction is, who the transaction was done on, how much is the loan amount, how much is the deposit amount, and all of that. On the other hand, there may be 10 different nodes in the network. They all will only see, because it's a ledger shared by every node. They have to keep a copy of that node. That is what blockchain is all about. So they will all see that bank A did a transaction with warehouse A. They will know about the transaction, but they will not know what the transaction is, how much was the transaction for, what constituted the transactions. So that is very important. Make sure that, I personally believe that you will find most use cases in consortium blockchains, especially in the industry, if you're going for that. All right. Taking a step further, so any questions, again, I'm reminding you, please write in the chat and I'll immediately take it up. We are well on time, and I think we can, we are not well on time. I see we have 40 minutes or so remaining. I'm sorry. So I'll go a bit fast, but you can write the questions, please. Or else I'll keep the last 10 minutes for questions anyways. So enterprise blockchain advantage, if you're talking about, this is, I just wanted to take a step further in helping you understand, especially about consortium blockchains and what kind of advantage that they bring. Consider this to be a part of types of blockchain and how to go about building use cases for them. So in consortium blockchains, access privileges, as I just said some time back, access privileges plays a big role. You can exactly designate which node writes and reads what kind of transactions. For example, in our case, we know we have given particular rights to the banks and a separate set of rights to the warehouses. Warehouses cannot do loan transactions, right? Because that's the characteristic of the bank. On the other hand, the banks cannot do the characteristics of the warehouses. So on and so forth. So we have very specific characterization of what kind of role a particular node may play. This is only available in permissioned kind of blockchains. You can designate these roles to the participants. Talking about visibility and privacy, as I said, permission network blockchains such as Quorum allow for designation of the transaction level privacy, right? As I said, every transaction we can designate, if it's between bank A and bank B, all of this can be designated that who are the recipients of that particular transaction. That is the kind of visibility and privacy which is unheard of in any public blockchain. That is not possible there because everything is public again. No lock on that. Also in private blockchains, this kind of visibility and privacy is not there. Privacy is there in extreme amounts in private blockchains, but in case of visibility, that is not clearly defined. Data and transaction storage. In consortium blockchains, you can very well, this you can do in private blockchains as well, to be honest. But yeah, most use case in consortium, so I'm discussing about consortium. The data and the storage of transactions, you can very well segregate, you can designate places, and you can store them on the blockchain network. You can decide to store the transactions of the data on chain or off chain. Mostly people store all transactions on the blockchain and any associated data on off chain solutions, such as a MongoDB or something like that. And then you couple and you show it to the customer. That is one benefit that you get with almost both the kinds of blockchains, which of course you can use in consortium as well. And execution and mining. This point again goes a bit close to the incentive mechanisms in consortium blockchains, which we'll take a look at. So in this scenario, right, the mining part of the blockchain network of the blocks can be given to certain designated nodes. We can make them leaders, and they can be only ones who are signing the particular transactions, right? So they are the ones. This might go a bit complex, but I'll try to make it as simple as possible. But once you do it via your hands, it becomes very clear, to be honest. And then I'm always available there. If you ever try these things out and you want to reach out, anyone, please make sure you do. So when you are designating a particular bank, say a bank node, we are taking an example of a bank node, that bank node will be able to sign all the transactions which are lending transactions. That is how you are enabling execution in the platform. On the other hand, when we are talking about mining, the incentivization, you can this is pretty much covered using a very a neutral approach. Certain you can say certain consensus mechanisms such as raft, which we use in quorum blockchain, and similarly IBFT. All of these are PBFT, IBFT. All of these are consensus mechanisms that consortium blockchains are very frequently using in today's world. And they have a very neutral way of mining the blockchains, mining the blocks. In Raft, one leader is chosen at random, and then again that the leader mines the block, goes back, someone else becomes a leader, and so on. It does not consume resources like proof of work does, nor like Ethereum's proof of stake does, or again Ethereum going to proof of stake now. So none of it is common here. It's a very neutral kind of a consensus mechanism, just to make sure the blockchain network goes on. Okay, again, this is talking further about incentive mechanisms. And as I said, that we'll be taking a look at 2 attacks on these kind of mechanisms as well. Let me check the chat once if there is any question. No questions yet. Okay, please do write. Otherwise, I would believe that my lecture is not very clear. Then I'll try to make it better. Anyhow, right? Please, there is any problem, write to me in the chat. All right. Otherwise, we will be done in the next 20 minutes and then 10 minutes for questions, and we should be done. So incentive mechanisms, let's take a look at that. What happens when miners become a part of a blockchain network? When a particular miner is taking a host of transactions and considering it in a blockchain, in a block, and he wants it to be mined, there is one aspect that miners think of, which is the value gain. As I said earlier, and right now also, every Bitcoin miner is behind this value gain only, right? Because they get 6.25 Bitcoins after mining every block. That mining a block is definitely has become harder and harder. But then again, there have been so great devices like ASICs and all, which continue to provide great value to the miners, right? So this is one aspect. One incentive mechanism is always to generate the value from mining the particular blocks in that blockchain network, and in return getting the native currency of the blockchain, that particular blockchain network. For example, Bitcoin in case of Bitcoin network, Ether in case of Ethereum network, and so on. That is one value gain, and this is usually applicable in public blockchains. Please make that sure. This is barely available in private or consortium blockchains. I have a chat. Claire has said, kindly explain who miners are and what they do in the blockchain context. Perfect. I'm sorry if I've gone a bit advanced in this without explaining that mining concept. Who miners are basically, some of you might be knowing, but it's best to clear it out. I should have done that myself. I'm sorry. What miners do is basically they just keep the blockchain intact by making sure that we are using cryptographic security, you can say, a security mechanism, which adds to the security of the blockchain network. Let's take an example and understand this, because all blockchain networks are currently doing mining in a different fashion. There are many consensus mechanisms. I have not included that in today's presentation, but I usually deliver those because they are very important. But I wanted to keep this a less technical. So there are different kinds of consensus mechanisms. Let's take one very popular example, which is used by Bitcoin, which is proof of work. What happens in proof of work is that miners who are mining the blockchain network, again, what is mining? Nothing. It is simply picking up a set of transactions, considering it in a block, and then the miner is every miner on the network is posed with a particular cryptographic problem. The only way to find an answer to that, this is all I'm talking about proof of work. The only way to find an answer to that cryptographic problem is by hit and trial. No other way. You, in fact, in the case of proof of work, you already have the answer to the crypto problem in front of you, but you cannot do anything because you cannot decrypt. These are secured by, these are encrypted by, for example, Bitcoin uses SHA-256 hashing algorithm. Bitcoin, in fact, Bitcoin does it twice. Bitcoin first takes the set of transactions, does a hashing of with a SHA-256, then whatever they hash they get, they again hash it via SHA-256. It becomes very hard to crack that kind of a thing, and that is why no one has done yet. So that is how the headers in a Bitcoin block are formed. So when we are talking about such cryptographic measures, the only way for miners to find a solution to the problem is by hit and trial. That is why the devices used for mining, say, Bitcoin blocks in proof of work, their only job is to hit and try millions of transactions, millions of trials per second to reach at a conclusion. And whoever out of 10 different miners, for example, whoever is the first person to arrive at the solution which is given there, which in the Bitcoin case, again, I'm trying not to go very technical, just a hint, you can learn more about it on the internet. In the Bitcoin's case, it is basically, finding that answer which has a set of trailing 6 or 5 or 7 zeros at the leading 5 or 6 or 7 zeros at the start of the final hash. That is when you know that you found the answer. So, but then again, huge complex cryptographic calculations go behind finding this answer. When you do, whoever is the first miner to do so, the network accepts him as the miner. The block of transactions that particular miner considered as a block goes and gets attached to the Bitcoin blockchain. And you can say, so what happens is that there is, I'm going a bit technical, there is a pool of transactions that whenever say I send one Bitcoin to Mr. Kayode, that transaction will go on the Bitcoin on the pool, which is called mempool. It is called mempool, technically called mempool. From that mempool, any next miner will pick up n number of transactions, say 100, say 50, say 25, say 10, any number of transactions he wants, the miner wants. After that, he would know what problem to solve. For example, if my transaction of one Bitcoin to Mr. Kayode can be a part of 7 out of 10, 7 different blocks, which are being mined currently, right? 7 different miners took the top 50 transactions from the pool. So my transaction was there in the top 50 transactions. So it got picked up by every miner. But whoever will be the first miner to find the answer first, whose block will be considered, that block of transactions, it could be any n number of transactions, that will be attached to the Bitcoin blockchain eventually. So if my transaction was picked up by that particular miner, it will be confirmed in the next block, whenever that next block comes into picture. So that is, and again, if you remember, I said based on incentive mechanisms, that is where incentivization comes in. The choice of the transactions that a miner picks is completely based on the miner's availability of resources, as well as what are the transaction fee attached with every transaction. That is what lures the miners into picking up your particular transaction if you're paying more than anyone else is. Because once you mine a transaction, there are 2 ways of incentivization. Please remember this. Number one, in the case of Bitcoin, you get 6.25 Bitcoins. As a miner, you get 6.25 Bitcoins on mining every one block. Just some time back, until in 2020, it was 12.5 Bitcoins. It gets halved after every set of number of blocks. It just got halved to 6.25 Bitcoins now. So what happens is, apart from this 6.25 Bitcoins of the native currency that they get, in addition to this, the miners pocket all the transaction fees that are associated with every transaction that they picked in their block. That is the reason why miners usually prefer picking the transactions with the highest transaction fee attached with them. That's basically it. So that's how mining works. And the proof of work consensus mechanism makes you do work to find a particular answer. Which is the work? The proof of work is the work that you solved using millions of trials and errors. You solved that particular question, you spent a lot of electricity, a lot of resources, and a lot of time on it, and eventually you found the answer. This shows the proof of work that no collusion had happened, no bad actions had happened. It is all clear. You really did the work and you put the miner block in the place. That is one. That is how mining works. I hope I've answered your question clear, and also I hope that this was valuable information, because it is one of the basic concepts of blockchain that we should know. So that is one kind of incentive. I see a chat. I see that Shyamaka has, I hope I'm pronouncing the name correctly. How can somebody be a miner, and is it possible for a transaction on public blockchain never to be approved? Very less chance, to be honest, because there is a set. So first of all, how can somebody be a miner? You can join a network. You can join a network like Bitcoin. You can bring in your. There was a time when Bitcoin could be mined using your own MacBook computer, right? Your laptop is sufficient. Now even big mining farms exist, and the you can say the hash rate has gone so high, which has made it so difficult to mine bitcoins, that people with huge ASICs, which are ASIC is basically like this. It is application specific integrated circuits. These are computers, these are machines that are made specifically to mine such transactions. Then there are various kinds of ASICs, right? So whoever is into Bitcoin mining, they usually find the perfect device, perfect machine. They attach it to the Bitcoin network. They download the Bitcoin CLI, and then they participate as a miner. That is how you go about being a miner. For every other network, there is a different process, easily available, because public blockchains want you to be miners on their network, right? They want more and more miners, right? So it is available, readily available information. And apart from that, into your second question, that on public blockchain never to be approved, very less chance, because always, say for example Ethereum. I'm sorry if I'm going a bit fast. I have less time. That's why maybe. So when we are talking about Ethereum, say, there is a gas fee attached with every transaction, right? So there is a minimum gas fee that the network defines you to pay. You cannot pay below that, and so that mining fee is sufficient for the miners to pick up your transactions. So even if right not in the next block, but maybe in the second block or third block or fourth block, people will eventually pick your transaction, because no one wants to leave out even pennies on the dollar, right? So that is why there is very less chance. If it is a good network, if it is a huge network, more the number of nodes, the merrier, you remember. So if it is a good large network, there is almost is practically impossible that your transaction will be there forever. But yeah, one thing, I have not put it on my slide, but I usually deliver that. One use case was, please take a look at CryptoKitties. You must have seen CryptoKitties being very famous back in 2018 or 17. When that CryptoKitty launched on the Ethereum network and then suddenly became famous, what happened was that it choked the entire network. For that, during that duration, I think 20 or 23,000, or I'm not remembering the number now, but a huge number of thousands of transactions were pending at that time for a long time, right? And it actually choked the network, Ethereum network. That was the longest time, maybe some transactions, and I was part of that time. I remember doing a transaction at that time, and it did not get approved for maybe quite a few hours, to be honest. That does not happen in real life in general now, right? That was one case. You can take a look, out of scope of this lecture, but you can take a look what happened when CryptoKitty got launched and got really hyped out. All right, going ahead quickly. I hope I've answered your question, Chiamaka, I think. Yeah, that's the name, right? I checked. I hope it's pronounced properly as well. Another type of incentive mechanism is that of a TAT gain. This is very specific to, this is not at all specific to public blockchains, does not happen there, very uncommon, but very, very common in consortium blockchains. See, in consortium blockchains, the miners or the nodes don't have any other incentive apart from certain business incentives, right? So what are the kinds of business incentives? Okay, thanks a lot, Shyamaka, thanks a lot. Perfect. So in that gain, it is when, so for example, our blockchain network has banks and warehouses and nodes, and us as nodes, right? We are not giving out bitcoins, handing out bitcoins to mine the transactions, right? So the incentivization mechanism in such blockchains, consortium blockchains, differs greatly. So here, all the nodes want one thing. So in our case, for example, all the nodes, even the warehouse, us as well as the banks, they need one thing, that the farmer gets the loan as fast and as quickly as possible. So that is why they are a part of our blockchain network and our business network as well, because they want a seamless lending to happen to the farmer, because that benefits the entire business altogether. So that is the kind of incentive. It might not sound like a direct incentive that, okay, why? Here I'm getting 6.25 bitcoins. Here I'm just getting what? A TAT gain. A TAT is basically, I'm sorry if I've not written it down. It is turnaround time for people who don't know. So turnaround time is the time which it takes for you to come back to me with a service. So like for us, it is loans to farmers. So if we take 10 days, that is our TAT. If we take 10 minutes, that is our TAT. So in our industry, in our segment, where we just came out with a blockchain network, previously when we were not there, this loan used to take 7, 8 or 10 days. Now on our blockchain network, because all banks and warehouses are on the same platform, it takes less than 10 minutes or few minutes, 20 minutes or so to get the loan done. That is one gain that currently all our stakeholders and nodes get from the network. That these are two very diverse kinds of incentivization mechanisms that are there. In addition to that, I created a division. I wanted to talk about two kinds of issues that can happen regarding incentive mechanisms. manipulating consensus. You know what can happen when, for example, in our node itself or in a private network, for example, in a consortium network, it happens rarely. In a private network, what happens if, not in a private network, I'm very sorry, in a consortium network, what it can happen is that if one of our banks wants to do some collusion and wants to, delay the transactions in happening, what will happen is that other banks will also not be able to process the loans. That is the kind of business game a node might play. It is very unlikely, but it is theoretically possible. So that is one business issue that can happen, especially in consortium nodes, that if a node particularly blocks the transactions from happening in some fashion, by either by not mining their own block or not allowing transactions to happen via their nodes or something of that nature, the network will suffer as a whole. That is one problem. On the other hand, in certain cases, in certain blockchains, what nodes certain participants can do is mess with the oracles. I'll tell you in one line to cover it quickly what oracles are. Just like in everyday.
Here, I've told her, we need the stamp, give me the stamp by the way.
Question?
I've told her, cool, there's a discussion around Kiambu reimbursement. We'll discuss it on Thursday. We'll dedicate Thursday for a meeting. So she let us do Thursday.
The option
It's
to
unfortunate that she's not going to, but it's because like you agree with me. Would you approve? Yeah.
Okay, we'll wait for Mr. Kayode to. If you're there, please unmute. You've just sent it to me, I think. Yeah, okay, perfect. Miss Lorraine has just. Thank you so much, Miss Lorraine. So I'll quickly continue. So oracles, in one line I was saying, oracles are such external data sources which provide information, external information, say for example, climate, weather conditions, or the stock prices, right? Prices of a stock in any of the stock markets, or maybe any such kind of external data to any blockchain network. Blockchain networks can't just communicate with external APIs. They have to have these kinds of oracles in between to get the external data. So if someone messes with that oracle, then the data that a blockchain network will get will be bad. It will be maligned. In that scenario, the network or the smart contract especially will be acting on that wrong data, which might create a bad business proposition. Again, another kind of attack which happens in incentivized mechanisms where people want to collude and want to take unfair advantage of any role that they play. Say, for example, a bank has been given the role of leading all the transactions, right? Of signing all the transactions. And then the bank node decides that, okay, I'll stop signing transactions now so that any other bank can also not sign transactions. That is bad behavior, and that can create some problems. It is unlikely, it is theoretically very unlikely to happen because you have, every node. It's not a public blockchain, it's a consortium blockchain. You know everyone, you won't let that happen. And then again, theoretically, these are possible. So always good to know, right? So this was incentive mechanisms. I'm done with this section. We'll now quickly take 15 minutes, take a look at a few use cases, and then we'll be done with it. Any questions now, please, you may put in the chat, or I'll move with this last section of the lecture. Okay, I don't see a chat, then I'll move ahead. If there is anything, you can just write to me again. Perfect. So let's take a look at blockchain and innovation and certain enterprise applications, very good enterprise applications that I personally feel very likely to be successful on blockchain networks. Two of them by very big companies, one of them by my own company, and we'll take a look at that. Before that, as I promised just some time back, I wanted to show, because this is a part of the maybe integration part of this. This is not a direct use case, but definitely a future use case. Let us see why you cannot buy, even till now, you cannot buy coffee at a Starbucks near you by paying Bitcoins there. Let me see. So sometime back, Mr. Alexander said that for Bitcoin, it is up to 10 minutes. For Ethereum, it is 15 or 19 or 17 seconds in between that. Did you know that Visa's transactions per second, the throughput, is 1,736 transactions per second? That is the maximum that the Visa network has faced. And this was a day, I remember reading it online on a news piece, that this was a day when they received 150 million transactions across the world in one single day. That was the day when they received the highest transaction per second throughput. And they have promised up to 50, they have their integrations and they have their infrastructure to handle up to 56,000 transactions per second, which is so far away. It is 50 times what we are seeing currently to max out. On the other hand, Bitcoin is 4.6 transactions per second. Huge gap. Another problem is that when you're paying by Bitcoin, you are even not sure that it will happen in 10 minutes, right? It might sometimes one block creation might even take more than 10 minutes as we were seeing at that number. It can, you can go, I don't think time will be there. Otherwise you can go and take a look at any of the blockchain explorers and see when was the last block created. See the difference of time between all those blockchains or all those blocks on the Bitcoin network. Some block could be created between 10 minutes. Some could be created for after 20-24 minutes and so on. So this doubt, this doubtful nature of the transactions makes it impossible for your regular Starbucks to start accepting Bitcoin payments. As you can see, Visa has 380 times Bitcoin's throughput. So whenever the number of transactions grows, it would happen like 100 people are standing in line in that particular Starbucks who are trying to pay via Bitcoin, because none of them knows. Not even the Starbucks barista, not even anyone in the line. None of them know that when a particular person's transaction exactly will be processed. It could be like within 10 minutes. It could be 50 minutes. Go and see a blockchain explorer. You'll see this difference live. All of it is public data. There has been no technology in the past which has been such public in nature. You can go and see everything. You can not only see the first transaction that Satoshi Nakamoto did, you can also see, just do a transaction and see your transaction there as well on the public blockchain network. Very important here. You do take a look, and I'm always available to help you out, right? So that is why I just said that you cannot, because you do not know that when your coffee would arrive or when your payment would go through to Starbucks, because it can take 10 minutes, it can take 40 minutes. It is uncertainty that creates the problem. If you knew that it is for sure 10 minutes, you would have still waited, but you do not know exactly, right? So that is the nature of this issue. Quick roundup before we take a look at those three resources, those three use cases. We have very less time. I'm sorry if I'm going a bit fast. There is so much to share. Blockchain is so vast, and I'm so passionate in sharing all of this with you. I sometimes go very, very fast. I'm sorry about that. So you can check on the screen. You can read it out as well. That what Visa has to do is just a payment infrastructure network. What Visa has to do is payment transactions processing, and that is 1:1. I go online, I use my card on a Visa-enabled website, and I get my payment done, and that is 1:1. My bank is taking care of that via the Visa network, and I am the only person. On the other hand, and that is one ledger, because these are centralized systems, there is one ledger where they need to write this transaction down, and at the end of the day, they reconcile it. On the other hand, Bitcoin has to tell the same transaction that I paid 1 Bitcoins to Mr. Kayode to maybe 10,000, 15,000, 20,000 different nodes who are keeping a track of that Bitcoin ledger. Geographic problems aside, this is a humongous task in real time to communicate with everyone that this transaction has happened. Please update your ledgers respectively. Huge problem, right? On the other hand, Ethereum network now, because it provides a second generation network. There are different generations of network. This is a second generation network. So on the other hand, what happens eventually is that Ethereum gives you the ability to build smart contracts as well, right? What happens in the case of smart contracts is there's a lot of data to be processed. There's real-time data, and then smart contracts are pieces of code which act on that real-time data and do certain actions, just like normal code, but these run on blockchain. So Ethereum network is not only having to provide an infrastructure for the Ether transactions, but also for the immense nature of the smart contracts that are being run by every other organization on the Ethereum blockchain. Again, huge data to be transferred all through the ledgers in real time, right? Very different from what Visa has to do. That is why things are so much developing. Before proceeding, next is use case. Before proceeding to the use cases, I would like to cover in 1 minute or 2 minutes, I would like to cover the generations of blockchain. I had skipped it out because of lack of time, as we can see, but I believe it is very important to just tell you about the generations of blockchain if you already don't know. There are currently we are so first generation of blockchain came with Bitcoin, which was just a transaction based, currency based blockchain in nature. That's all that Bitcoin does. Bitcoin allows you to do Bitcoin transactions, and that is all. The second generation of blockchain came with Ethereum at its centerpiece, and Ethereum allows you to not only do transactions on the network, but also write code, deploy those code on the Ethereum network, and they run on real-time data. This is a very new, that is why Ethereum, people call Ethereum to be the world computer, right? Because this is the new form of functionality that Ethereum brought into the world of blockchain. Second generation, that is the second generation, and that is the generation currently most stable at the moment. Third generation of blockchains take care of features such as sharding. What is sharding? People who don't know what is sharding, sharding is basically dividing the data into different areas so that one blockchain network or in database, sharding means that one database does not get so heavy that it's difficult to work with. So in blockchains, they divide the data into maybe separate places. Then there's sharding. Then there's interchain connectivity, right? Cross-chain connectivity. You can say that is talking between two different chains. There is side chain functionality, another feature of third generation blockchains. Side chain functionality is there is a one main blockchain network, and there are side chains of that same network where you use those side chains for certain kinds of activities, such as for sharding the data between those two chains and keeping all the unimportant pieces of data in the side chain and only the important transaction level data on the main chain. These are all methods to increase the throughput of blockchain networks, because people saw that first and second generation blockchains were not able to be very fast, as you can see on the screen itself right now. So that is what third generation blockchains were working on. They have been very successful till now. People have received thousands of transactions per second on the blockchain networks as well. So very close to Visa, you can say, or such networks. But they are not into very much of mainstream production right now. See, even free Ton, you can see it's 0.2 seconds. So these kind of transaction throughputs can really be used in real-time scenarios. So if you want to pay for your coffee at Starbucks, you can use free Ton if they accept, right? If they want to, they can, because you know that within like 0.2 seconds or within a second, you'll have that block ready. The block will go into the free Ton blockchain, and I don't know the technical nature of the free Ton blockchain. Maybe Mr. Alexander would be better placed to talk about that. But then again, with this kind of block time, you would know that it is moments before which your coffee transaction will go through, unlike in Bitcoin or Ethereum or such blockchains, right? All right. So and going ahead, so that is third generation, and then fourth generation are people still experimenting. Let's not go into that. All right. Any questions, please write in the chat. I am, so Mr. Kayode, how much time do we have practically? I have 3 use cases to share. How much time do you have? I'll go ahead. If you could just let me know about the time, then I'll tune it accordingly. So, but let's not spend any more time. So one use case that I wanted to share with you to give you a great idea of how blockchain works is when IBM, let's take a quick look at it. You can even read the text on the slide to go quickly. IBM came out with this food trust blockchain that they built, and they put an entire supply chain on the blockchain. So currently we know, there are people, so many people dealing with supply chain management issues. Blockchain solves many of them. So what IBM did was they went all with blockchain and IoT information on their food trust blockchain. And with that, they tried to provide the end-to-end information of a supply chain to the consumers, right from where that particular commodity was grown, sown, harvested, which warehouse it went to, which factories it went to, when it got processed, which distributors it went to, and eventually when it got delivered to you. And then you can scan and you can see all the data in front of you as a consumer as well. That is one way to create less friction and maybe a more global approach. And IBM being a very global company with great use cases, they carried this out very successfully, right? Another use case, I could have delved deeper into this. We are lack on time, but you can go ahead and you can search for it and you'll find an entire white paper on this, to be honest. Big use case. This is one use case that I liked a lot, because previous to this startup, I was in an insurance aggregator, which is India's biggest again. I was there. And insurance using blockchain, they don't use insurance on blockchain, but many have tried this out. And Accenture did this particular use case research that insurers can really put insurance and claims on the blockchain, and you can read the numbers. They can prevent, I mean, they can save between 99 to 277 million dollars annually just by doing claims and insurance on blockchain. insurance domain is definitely very, very complex in nature, and people have usually faced a lot of problems. And with the use of, so Accenture wanted to has done an entire case study on this, and they wanted to bring together IoT sensors, then oracles, which take data from the outside world, and then put all of that into blockchain to help process claims at a much faster rate. And this brings in a lot of savings to the insurance companies as well, which is the numbers that you can see on the screen. Big use case. Again, a big company, Accenture, you can read about it. Very quickly going through what we have done. Again, I would have, honestly, I would have not put this if we wouldn't have done such big work in India itself. This is not an advertisement, to be honest. There are huge frauds that have happened. $3 billion in Qingdao scandal happened in warehouse receipt finance segment, again, a fintech segment, right? And to be honest, these had names such as Standard Chartered, Citibank, all big names who were hit by this fraud. Then in India, it was $1 million NACL scam back in 2015 or 16 or so. So using blockchain and IoT, in this particular segment, we are trying to eradicate a lot of frauds which are faced by big and major banks, not only in India, it is across the world. Qingdao scandal was in China, not in India. And big names have faced this problem across the world. That is why the state governments in India and also banks, major banks, are very happy to work with decades. And with that, you can see on the screen, with that we have actually implemented this. That is why we tell that it's the largest agri fintech blockchain in India, because we are implemented across 1,400 warehouses. And these are not people who know blockchain or are computer science engineers. These are very normal people who are running warehouses, but they are happy to use this platform because it is not tough. It is not at all tough. Just because it is blockchain, it is not tough, right? And within 8 months, we went to 1,400 warehouses across 5 states of the country. And the Indian government is also happy to see this kind of an implementation in blockchain being done at such a massive scale. And we are only growing. And in India, unlike in US, we do not have 4,000, 5,000 banks. We have very few limited 18, 20 or 25, 27 banks in total. Out of that, 5 banks are already on our 5 lenders and banks are already in discussions on our platform already. So that is something we've done. And we've done more than $1 million of loans within the last few months. And we have over $500 million of commodities tokenized on our platform, more than $500 million of rice, grain, and cereals and pulses and everything that have been stored in our warehouses that have been tokenized and put on the blockchain network. That is why it is one of the biggest in the country. That's all. I am done. If you have any questions, you can write to me. I'm on LinkedIn, I'm on email. WhatsApp is the best way to reach out. It is on the screen, and happy to help. I'm doing a lot of work in blockchain, and if anyone else is doing as well, happy to collaborate. Any questions? Otherwise, I see that we are almost 1 hour 30 minutes. So I believe I've ended at a good time, Mr. Kayode. I hope.
Alex, thank you very much. This has been a very insightful discussion so far. I mean, it's so much rich and the content has been deeply vast. I mean, we'd like to thank you for coming around today to tell us about blockchain, the background, and also even educating us much more further than we even plan to even learn from you. And I'm sure the crew here today have some questions. I don't know if you have some questions, we can actually drop the question in the chat box, or by raising your hand, we can also do that to ask question. Thank you very much. Somebody's saying,
just one.
Yes, please.
Yeah. One request before I take a question. One request. So please, I've just given out a link on the chat. This is a really 10 seconds feedback. Anonymous. Don't have to put your name or phone number or anything. Just you need to write how this session was, so that I can. I've taught more than 4,000, 5,000 students and faculties, right? So this is a way I improve my next lectures. If you just give me feedback on this one. One feedback could be that I went very fast, something that I've received. I've tried changing. Please do fill the feedback form. Just click on it. It'll take you 7, 8, or 10 seconds to fill it. Promise. Yes, please. Any questions? Anyone? Please unmute and you can tell. Any questions? Any questions? Claire, Shyamaka? Any questions? Mr. Mutemi, Joseph, you came up with that 17 seconds for Ethereum. Any question? Titose? Olive? I'm taking out names. Any questions? I'm happy to answer. I mean, from use cases, I'm expecting some questions. If not, then we can be happy to drop out, Mr. Kayode. Okay, thank you so much. No questions. Thanks a lot, Joseph. Glad to hear. Mr. Mutemi, that was amazing for me to hear. Please do click on that feedback and leave it in that feedback as well, so that I always remember it when I read it and I give the next presentation somewhere, or maybe with Africa Blockchain Institute if that happens again. And so please let me know in the feedback. Yes. Anything else? Otherwise, Mr. Kayode, we can drop off. I don't think we have questions. I took quite a lot of questions in between as well, so maybe people are up with their questions.
Okay, thank you very much again. So you can still hang around because we are now proceeding to the core of today's program, which is the from the Ton Lab. We have the lead engineer, the CTOs, and also we have the co-founder here to bring up to speed happenings at the Ton Lab and how we could get the student to build the product on the Ton Lab. So I will have to hand over to Mr. Alex Randa to lead us on the Ton Lab and also introducing the rest of the team at the Ton Lab here today. I know we have Mr. Ron and also Mitja and Pavel. Any of you guys, I'm so glad enough to introduce yourself so that we can get this program going. Thank you very much.
Perfect.
Kayode, thank you very much. Without kind of saying more, I would like to hand over to Mitja Goroshevsky, who is co-founder and CTO of Ton Labs. Mitja, great to have you.
Yeah. Hi everyone. Can you give me the screen, please?
Yeah, I'm trying to, Mitja, I'm trying to escape out of this. 1 second, please. Give me one second.
No problem. No problem.
Okay.
So let's dive into a little bit more kind of technical, and I will just give a short presentation on the capabilities of the Ton blockchain and how it's all structured and what kind of tools it has. And you can, I planned it like for really short, and then I will hand over to Katya and Boris, who are leading the tools for developers tools inside Ton Labs, and they can talk more in depth about these tools and how to use them, and how to write smart contracts in Ton. So if you will have any question, just drop in the middle, whatever. And so I will just give an overview. So the Ton blockchain is the latest generation blockchain. It's quite unique also if you compare that with others of these kind of generation blockchains. And that what we regard this current generation, the latest generation blockchains are really just, I would give several names. Maybe you heard of them. It's Solana, Near, Polkadot, and more or less that's it. There are some others also, but they're like much smaller, and also I don't really know if they work. So if you compare Ton with these blockchains, okay, so Polkadot is a blockchain which is a sharded blockchain. Okay, so it has let's call it Masterchain, and then they have what they call parachains, which are something that you can create your own blockchain, and then you do something on this blockchain as you wish. You provide some guarantee, which is basically taking money and give that to the master chain. So you guarantees with this money that what you do on your parachain is correct. And then inside your parachain, you can do whatever you want. The problem with this approach is that if you want to do cross parachain transactions, you want to do an application between and the transactions between the chains, then you have a problem. It's slow, and it doesn't scale in that respect. So the scalability of Polkadot is really constrained by the scalability of the chains themselves. So it's like it's just one chain blockchains which put together, okay, with some kind of guarantee in the middle, just to be very kind of high level. You have another approach, which is not sharded approaches, which it's like Solana, Algorand, several others. But Solana is really taking that into extreme. What they do is that they create one chain, but this chain is really, really fast. So they have a 0.4, currently 0.4, 0.5 seconds block time producing. And it's achieved by extensively using GPU. And they do something, basically they take time and they divide this time by very small slots. And in each of the slot, you can produce a block, only certain node that can produce the block inside this slot. So they have they put the order of all the validators, all the nodes, and they try, and because they have this order, they can predict when someone will be the next, and they optimize the whole blockchain to work in a way that every validator will produce the block inside certain amount of time, and and for this node it will not happen very often. It will happen once in a certain amount of time blocks. So in this way, they do something which is very similar to what, because actually Anatoly Yakovenko came from the background of the Qualcomm, they do something similar to what are wireless networks doing in something called time division multiplexing. And another approach is what Near protocol, and what we're doing in Freeton is to have it a sharded blockchain, meaning several chains, but working in a concert in a way that they all submit the blocks to the master chain, but in between these chains or smaller chains, there is an instant communication. Okay, just let's put it in, again, very high level. Freeton takes that to the extreme. And the difference between Freeton and all these other networks is that not only it is sharded, it is also actually multi-threaded. If you know what multi-threading, so the sharding is, I think previously was said that the sharding is in the database is sharding the data. So you take a subset of data and give it to one node, in this respect, several nodes to run, and then another shard. But sharding the data doesn't really solve the throughput problem, because in databases is done because you have a very large data, so it's very hard to manipulate this data. But in blockchain, you're not manipulating all the data backwards. So it's kind of solving wrong problem, because we actually don't have problem with data. The disk capacities are growing and they're becoming faster and faster. You have today NVMe SSD disks of the several gigabytes. It's not a problem to store the data. What is really a problem is to execute smart contracts fast. When you think about that, you have maybe hundreds of thousands of smart contracts to execute simultaneously. Sharding the data won't help you. What you will need is sharding the execution, sharding the processing time. And sharding the processing time, called multi-threading in computing science. So what Freeton is doing, and that's a first in the world who is doing that, it's actually inside one shard. You can have many shards, you can have several shards, of course, but inside one shard, it's sharding, it's multi-threading the execution of smart contracts. So what happens is that you have, say, 1,000 validators inside one shard, and then you have segments of these validators who are rotating every 4 minutes, executing one thread of the smart contracts and supplying the proof of this execution to the master chain. That way, we can actually parallelize the execution of as many smart contracts as we want, basically. Just basically, the limit is the size of the validator set, right? So this blockchain has been done by Telegram. Wrote this piece in the right corner, which is the basically C++ execution of this multi-threaded, sharded, let's call it a processor, because if we think about blockchain as as a distributed computer, right, as one like world computer, as Ethereum once called it, then we really think about the execution part of this computer as a just distributed processor, correct? So what we have in Freeton is this multi-threaded processor distributed. Now, Ton Labs has implemented the Rust variant of this protocol. So we have this validator node that is written in Rust. And on top of that, we have developed something we call Ton operating system. Now, we call it Ton operating system precisely because we regard the blockchain as a multi-threaded processor. Once you have a multi-threaded processor, or any processor for that matter, in order for the user to start operating on it, you need what it's usually called in computer science an operating system. And so operating system is everything in between the processor and the user application. So Ton operating system is a vertically integrated stack of technologies which sits on top of this distributed processor. So of course it supports multi-threading. It has a Ton virtual machine, which is the computing platform, something that executes actual smart contracts, executes instructions. It has, validator, collator, everything like network protocols, consensus protocols, all that, which basically and resources of this processor. And then on top of this, you have something we call a middleware, usually called middleware in operating system design. So these are compilers, SDKs, and a toolchain for developers to actually being able to develop applications. And Katya and Boris will talk about exactly this part for you in a little later. On top of that, we have written a lot of smart contracts, which are actually like building blocks for the whole network. We call it system smart contracts. And this includes the smart contracts that manages the validators, which is called the elector, that are distributed pools for staking, so everyone can stake. And Freeton, by the way, it's not a delegated network, so there is no delegation in Freeton. You stake your tokens either by becoming a real validator or by staking into the decentralized pools called DePools. But you vote, if you want to vote with these tokens, you're able to vote with them and not your validator holding them like in pretty much every other network. Like if you want to, if you have a small amount of tokens and you want to stake these tokens in Ethereum 2.0 or in Polkadot or in any other proof of stake networks, you will go to large validator and you will give them your tokens and they will stake it for you. We don't do that. We don't like that because this is a centralization point and you actually giving up your tokens, and we can see that as a dangerous potential attack on the network, because if someone will accumulate a lot of other people's tokens and can vote with them, then that's a centralization of power. So in decentralized pools, decentralized pool is just a smart contract. You can stake your token in it, nobody controls it, and you can take it back whenever you want. There is a tokenized contract. And why I want to spend 1 minute on this contract is because the unique architecture, which I'm sure Boris will talk more about, unique architecture of Freeton blockchain is that because of how, first of all, it's like in other blockchains, you have two kind of layers. You have an address, which inside this address is like your wallet address. You can put tokens in this wallet address, like in Bitcoin, for example, or in Ethereum. In Bitcoin, you have a UTXO, of course, but let's say in Ethereum, where you have an accounting, like account-based blockchain, you just calculate your address. You can actually send tokens to this address. And then you have smart contracts, which are separate entities. In Freeton, it's the same thing. So you have account, and you can actually send tokens to that, but you will be able to use these tokens only if you deploy code there. So if you deploy code there, it means that every account in Ton which is active it's a smart contract. So it's like making it the largest smart contract platform, maybe even the ultimate smart contract platform, because you cannot do anything without having a smart contract. So because of this nature of this architecture, what we've been able to do is also to create an architecture which makes it of the smart contract, which makes it completely distributed. So for example, in Ethereum, you have something called the ERC20, and there are many other standards built on top of that, which is the tokens on Ethereum network, for example. So how these tokens are done? It's basically a ledger, one smart contract, which holds like a pair of your address and the amount of tokens you have. So if you want to have a token which is distributed to millions of people, you will have a smart contract with millions of entries. Now that creates a problem, because to operate, of course, on this smart contract, on this huge pile of data, it's very costly. It's the operation, like the operations you need to perform on this are becoming very heavy. What we came up with is the ability to make the token contract completely distributed. So everyone has their own contract and there is no ledger, but yet there is a proof and guarantee that the token that you hold in your wallet is actually, you cannot double spend. It's very interesting. I suggest everyone to read. It's called Tip 3. And there are actually, on top of that, we built a lot of other use cases for this token. For example, a distributed domain name or name system in Ton called Tip 2. It's also very similar to that. We don't need to, in order to have a domain name in FreeTon, you don't need to have a smart contract which holds all the domains. Okay, so basically we have this layer of smart contracts which we have developed, and now communities start to develop a lot on top of that. And I hope you will be able to do so as well. And then on top of that, we created something called DeBots. DeBots is decentralized bots. And DeBots is created because we thought Web3 architecture sucks. And let me spend 1 minute on how Web3 works. And of course, you know what Web3, right, is. So Web3 is a library, basically, which enables your front-end application to talk to the blockchain. So if you have a website, for example, and you have a button which want to read something from the blockchain or write something to the blockchain, you connect the Web3 library to this button, basically, and it performs certain function. Or to perform this function, it calls your wallet, which, for example, a MetaMask, and then through this interaction between this MetaMask, between the website, and between the Web3, you kind of can create a transaction and send it out. Why it is bad? It is bad because, first of all, it's very complicated for the user. And second of all, because it's actually a centralized architecture again. Why it is centralized? Well, because you put Web3 library somewhere, so you need to have a website. Now, if you have a website, you have a server. And if you have a server, you have a centralized point. Now, so what is the point of having a blockchain which is a decentralized, and censorship resistant, and all of that, right? Trustless and everything, and having a one website which you interact through with this blockchain, which this website can be controlled by someone, can be censored by someone, can be, and so on, the data can mutate, and so on and so forth. Web3 is trying to get around that by introducing like IPFS websites. So you hold your site on IPFS kind of storage, and then you downloaded it together with Web3 and all that. And that's kind of to get around the problem of centralization of the Web3 architecture. But it's very similar to how Ethereum tries to solve their problem with scalability by introducing side chains. It's not very feasible, like in real life. Side chains are creating problems because of the side chains need to submit the data to the blockchain. It takes a lot of time to synchronize that. Also, you have a problem of trust of this particular side chain because it's not you trust the Ethereum network with billions of tokens, their value, but why should you trust the side chain? And so on and so forth. What we have created is something called end-to-end decentralization and E2ED. An E2ED concept is where everything is happening in trustless manner from the user interface without introduction of any centralized entity whatsoever. So what is DeBots? DeBots are also smart contracts, but instead of being executed, they are stored on the blockchain, but instead of being executed on the blockchain, they actually executed in SDK, something that Katya will talk about. The SDK is a thing that runs inside your computer, and it has also virtual machine, Ton virtual machine, and you can execute the smart contract on your machine, inside your virtual machine. And this smart contract will actually act like a bot in a chat. And this bot will interact for you with any smart contract which runs on chain. So with DeBots, you have a very easy way. If you write your smart contract and then you write a DeBot for this smart contract, you have a decentralized interface that any user can now operate with your smart contract through just interaction with this bot. So for example, like if you want to create a wallet or multi-signature wallet, you just call this DeBot on your machine. It will be downloaded from blockchain through the node. You verify that it's verified that it's indeed the same as on the blockchain smart contract. And then you run it inside your virtual machine and will start talking to you, ask you questions. You can ask, you can try it yourself. By the way, it's very easy. Start asking you questions like about what kind of parameters of the wallet you want to create. It will create the message for this and send it without your even realizing that, send it to the blockchain, and your wallet will be created. So on and so forth. So these are kind of user bots. Now, of course, you can create any kind of interface on top of that and to interact with these DeBots. And the interface for this we call blockchain browser, because it's really like a browser of the web, where instead of HTML page, we show to the user the DeBot. Now you can create any kind of interface on top of that. If you want, you can create buttons, or you can put it in the conversation kind of style. But in the end, it's something that runs inside your local machine as a browser, interacts with the DeBot, basically showing the DeBot actions to the user, and allowing him to communicate with that, and then sending it to the blockchain through the SDK, all in completely decentralized way. So one of the browsers we built in Ton Labs called Ton Surf. Of course, I know many of you maybe already downloaded that, so you can interact there with the blockchain, sending transactions to each other and so on. There is also another thing that we're building. It's called Ton Card, and Ton Card it actually will be released, I think, this week to the developers. It's a secure enclave, just an NFC card basically. It has one Infineon chip inside of that, and this chip generates the private key inside the chip and never gives it out, so you cannot extract it. So this card can be used to be your kind of one of the signatures of your multi-signature wallet, for example, or it can be used as a cash card. Actually, you can load the cash inside the card. We can load the tokens inside the card and just give it to someone. And because this card does not reveal this the private key, the person who you give the card is very sure that you cannot spend the same tokens twice. So when you give this card, you give the tokens basically. So there are many other use cases that you can do with this card. For example, it can be used in like a guarantee. For example, for transaction, you can give a card as a one signature and leave a sum like escrow and so on. And of course, you can secure your own account with that, because you can have several of these cards as a signatures to your multi-wallet account if you hold a lot of tokens. Well, I think that's kind of an overview of the architecture that Ton Labs is building. It's what we wanted to do for the developers. The idea is to have a system where you can create your applications as easy as you would write an application on, for example, the Firebase. So instead of going and, you know, assembling your like technology stack from different places like you would do in Ethereum, where you have a truffle, then you have like somewhere else the debugger, then you have in Web3, which is the application, then you need to build the backend. On this backend, you need to build a database so that the database will download data from the blockchain for your users and then send it to your user's application. And for that, you need like several developers to do all that. We wanted to abstract all that for you like Firebase did for mobile developers. So you don't need to actually think about any of that. What you need to do is just concentrate on your application and developing your smart contract, your DeBot, and your front-end application without, you don't even actually need a backend developer. And you can use the SDK to communicate with the data on the blockchain just by installing the SDK. You don't need anything else. There is a cloud that runs for you. And this cloud currently is runs by Ton.live, but it will be, there is a sub-governance in FreeTon, which now creates a standard for how to decentralize that whole infrastructure. So like there will be a lot of people who will run this cloud for you. And what you need to do is just to put, you know, an address in the SDK, and it will connect to this cloud without you even, you know, thinking about that. Now, all the data is put already inside the database, and SDK is communicating with the GraphQL through the GraphQL protocol with this database. Now, you inside your application can create like a GraphQL queries, and if you and show the data to the user, it's all there. You can filter it the way you want without you need to think about this infrastructure. So we do all this hosting, and if you really compare it to, I don't know how many of you develop ever on Firebase, but you compare it to Firebase, like you think about smart contracts as a functions on top of database. You have a database, you have a functions on top of database, and then you have an SDK which supports many languages. By SDK, Katya will talk about that, supports now, I think, over 20 platforms. And you manipulate with this data, basically, and that's everything you need. In fact, you don't even need to create a front end. If you just create a smart contract and the DeBot, then like any FreeTon browser will be able to operate with this DeBots and will show it to users. So for example, Surf. All you need is just to give up to your users your name in FreeTon, the address of your DeBot, and that's it. Nothing else. Thanks. If you have any question, please shoot.
Okay, if there are no questions, I would like to make some very short comment to throughput where Mitja started. There is very easy to calculate the practical limit for throughput for one chain. There are currently physical limit of 1 megabyte per block. You can see it across different chains. Then if you take into account the speed of consensus and how many blocks per second or seconds per block your one chain has, and then take into account the message size, then you can easily understand that for whatever, so you can optimize your chain whatever you want, but then you will end up with low digits of 1,000 transactions per second for if you have only one chain. Since normal transaction consists signature, consists hash, should consist, and some projects which claim tens of thousands transactions per second for one chain, it's more like a trick. So if you reduce the security of your transactions, or you reduce the amount of cryptographical proofs, then you can show high throughput, but it is not the real message. This message cannot be used for smart contract interaction. And again, this is the most value in decentralized systems actually, when you have smart contracts and which can operate in the centralized way, because then you can run an arbitrary logic. Only transferring tokens, it is not, it has not that much value, because this is any smart contract platform will have ability to transfer value and transfer tokens, but what can you do with it?
Mr. Motemi, to your question about the cards, yeah, they what I mean distributed, you will be able to purchase them. They cost really little, like I don't remember precisely, but it's like 20 tons or something for a card or less, and it goes down with the quantity. And it will be, yeah, you will be able to purchase that, I think, by the end of this week, maybe beginning of next, for developers only. It's a developer release. They are programmable. You can create an applications which uses the card. So the SDK has a card smart this card library. So if you want to develop an application which has this capabilities to connect to the smart card, then you just this card you can just you know, download an SDK with its libraries and connect it to your application. Yes, the ability for this card that this card does not leak the private key is yeah, it enables it to be used in many applications, which are really cool. I agree. It's maybe overwhelming, like the amount of information. So again, let's handle it to Boris and Katya for the next part. Thank you very much, guys, and see you around. Unfortunately, I won't be able to stay. So if you will have any questions for me, just please collect them and I will be happy to answer, or you can ping me in Telegram anytime. Thank you, guys.
Okay, so who will be next? Me?
Yeah, please go ahead.
Okay. When I was preparing for this call, I thought about the easiest way for you to help you quickly get started with FreeTon. So I came up with some quick start guide, and we will briefly go through it now. So the first thing at this point that I encourage you to do actually is to go to test.org page and find the specs here, Ton, TVM, and Ton blockchain. And they're pretty big, about 150 pages, but I encourage you to read at least 30 pages of each of them to understand what is actually going on here right now, because we're in the stage of pretty low level development right now. I hope we will finally come to some Firebase-like thing where it's possible to somehow abstract all of this from you. But now these things are essential for you to understand actually what is happening here. So for this presentation, I also prepared some basics of FreeTon blockchain for you to understand the further things that I will talk about. And I think that this page is public. I will send it now to Zoom, or maybe later. Okay, I will send it in the end of my presentation. I don't know how to do it right now. So, okay, let's go through the basics of Ton blockchain. Very, very basics, like in 3 words. This is essential for you to understand all of the further information I will talk about. So at the moment, FreeTon blockchain has 2 workchains, Masterchain with the ID of -1 and simple workchain with 0 ID. So the master chain is used for service contracts, and the 0 blockchain is used for some simple user wallets. In turn, workchain splits into shards, so-called shard chains. When the load increases and when the load decreases, it merges back. It is validated by some validators. Part of them validate master chain, and others are splitted into groups and validate shard chains. Sometimes elections happen that switch the global list of validators, and within one election cycle, shard chain validators also rotate. So the next definition, account. Account is basically an actor in blockchain. It has some properties such as address, balance, and also it has a place to store its code, so-called contract actually, and a place for its data. So it can have one owner, many owners, or no owners at all. And the address of the contract can be calculated from its initial code and data when it is being deployed. I will say a few words about deploy now. It means placing code of the contract into the account, into the blockchain. So the problem with the deploy is that it's not for free like another blockchains. So it's important to understand that before you deploy something, you need to pay for it. So you need to sponsor that address beforehand. A little about money transfer. Mitja already mentioned that it's not possible to transfer money between accounts if you don't have any code. So the transfer is basically executed by the contract code. So do not transfer money to the addresses where you cannot deploy code, because they will stay there like forever. A little about commissions. I just gave you the link to the page where you can read about the commissions, the fees of the blockchain. Shortly, there is a storage commission that is paid for storage of account, and some commissions for message sending between accounts, and of course some commission for execution depending on the code complexity. A little about get methods. What is get method? It's a method of the contract that can be executed locally for free on client side. Another important thing to understand about sharding is that how to find out what shard my account is in right now. So the shard is basically defined by some hex in hex format, and it's basically representing the first bytes of your contract account address. And to find out what shard your account is in right now, you need to like put the shard prefix in binary format on top of your account address in binary format, and if this numbers like merge, then your account is in that shard. You can also read about it here, but I encourage you to go deeply into the specs of Ton as well. So message, what is message? Messages are all interaction in Ton is performed via messages. If you want to deploy your contract, you create a message and send it into the blockchain. If you want to call some contract on blockchain, you also prepare a message and send it into blockchain. When contracts communicate with each other, they send messages from one contract to each other, so-called inner messages. If you want to get some events from contract execution, you listen to the external outbound messages or events of the contract. So you can implement any off-chain logic based on this contract events. So transaction, what is transaction? It's not what it means in Ethereum here. Transaction, we do not send transactions in Triton, we send messages. Transaction is basically the action of contract execution. Transactions are usually, except for some system contracts, are generated by one external inbound or internal message, which means that by one message that comes into the contract. And as a result, it can generate several outcoming messages, both in external or internal. Internal transactions can be successful or aborted in case there are some errors in contract code, or maybe the fees, the balance wasn't enough and fees are too high, and so on. The next very important thing to understand is BOC, bag of cells. Bag of cells is actually, it's just simply a format of data packaging in Triton. You can find out more accurate description of actually the algorithm of this packaging in the specs, but for now I think it's enough for you to know that it's just some packaging format, and every object, account, transaction, message, even and blocks, they all stored in so-called bag of cells. And for example, if you take a bag of cells of a block, it contains bags of cells of transactions and messages that were executed inside of it. Okay, TVM, Ton Virtual Machine. It's a Turing complete virtual machine for contract code execution. It works with bag of cells. This is why you need to understand what it is. And actually, TVM does not calculate any commissions itself. It just runs the contract code and generates some external messages, outcoming messages, and it is used. It can be used locally on client side for get methods execution and DeBot engine. Mitja talked about execution. Also, TVM is used on validators, but on validator side, it is used together with higher level protocols. One of them is transaction executor, which additionally calculates commissions and performs other checks to validate the transaction. Well, and the last definition, I will say a few words more about transaction executor. It also can be used locally. SDK uses it for contract debugging, fees calculation, and so on. So it's the same component that is used on the validators, but it can be used also on the client side for debug. So it was the brief overview of Ton blockchain. So now let's go to Ton.live to see all of this actually with your own eyes. Here you can see shard chains, Masterchain, and zero shard chain. Here you can see shards when the blockchain is doesn't have any high load. It has 16 shards. When the load increases, they split, and so let's go to some block, Masterchain block. Here you can see transactions of this block, messages of this block. You can walk through blocks, go to previous one and to the next one. So here are transactions. I don't know, let's check some transaction. Here's the address of the account to which the transaction belongs to. Here you can see information about gas fees and so on. Let's go to messages. Let's check some, I don't know, let's check this message. So you can, as you can see, it has some child transaction that I told you about, like message generates actually a transaction, and there are no outgoing messages here. It's just only one incoming. Okay, so let's go to accounts. Here you can see some accounts. Let's open some account. Here you can see its address, its balance. If you click more details, you can see its code, code hash, data hash, and validators. Here you can see information about elections, but for this thing, I encourage you again to go to specs and read about elections there for more details. So, okay, so what's next in my quick start guide? The next thing you should do now, at this stage, is to understand how to create your first smart contract. Boris will tell you how to do it after me, and you need to learn how to compile it and how to get your TVC and ABI files. After you are like created your first smart contract and you understand how to do that, now we can go and review all the possible use cases you can implement with SDK. Just follow this link. So let's go and see. You can deploy smart contracts. You can send external messages to smart contracts. You can run get methods. You can run the bot engine, Mitja just told you about. You can debug your contracts locally. Also, you can query blockchain data, subscribe to blockchain updates, including contract events, and not only them. You can monitor message delivery. It's a separate complex topic about blockchain. Some messages, sometimes external messages are not delivered, and it is possible for this blockchain. It's described in Ton spec. So you need to understand this process of message delivery. Also, you can decode and encode ABI compatible messages to actually decode the information from contract event, for example. You can estimate fees. You can also, there's a crypto module where you can generate keys, generate mnemonics, and encrypt, decrypt data, calculate hashes. Also, we have a complex network layer where we provide some functionality to suspend or resume WebSockets, and SDK can work both via WebSockets and fetch. So, and also important thing about cryptographic module is that although SDK provides all of these functions to encrypt, decrypt, and sign and stuff like that. If you're having some wallet where you operate with some big sums of money, we encourage you actually to use external signing for that cases, and SDK provides some support of such an interface called signing box, where you can implement integration with your signing device such as HSM and NFC, or maybe some secure storage on your device, and to sign your messages outside SDK and then just put the signature into. So this is also possible with SDK. So you can use your external devices for signing without private key disclosure to your application and to SDK. So, okay, this was the overview of SDK use cases. Now, after you read all of this, you can go to quick start. Actually, it's here. You just need to read all of this. You need to have these prerequisites, Docker, Node.js latest version, and also we prepared for you already compiled contract. Hello, it's a simple contract that has like only constructor and just two methods. One method is a get method and another one is a simple method. And then you need to go through all of this instruction to, you start local node, you create this Node.js application, you configure your client to connect to the local node, you integrate your contract artifacts into the project. So you can see you connect its ABI and its code here. And then you deploy, you sponsor it with Giver. As I said, you need to sponsor your contract before deploying. Then you run some get methods of this contract. No, not even, just a method and then get method. So I already have, and also you can find this project here. In the beginning, you have a link to the full example. Here it is. I showed you already. So I already have it installed. And I will just show you now how to run it. Okay, so here's the code. So before we deploy contract, we calculate its future address from keys, and yeah, here we only use keys because we don't have any initial data in this contract. Then we use a local node giver to sponsor it with some tokens. Here you can see this step. Then we deploy, actually. And then we run this. Oh, sorry, I can wait a second. This one. Here's this one sample. So yeah, here we have this. We generate keys. We calculate. We encode deploy message. Then we calculate the future address, and then we sponsor it. Get grams from giver. You can go through all of the comments here in the sample to understand what is going on here. So then we create a message to call our function touch. Then we call it with process message function. And after that, we execute get method with run TVM and get our timestamp from the contract. So this is it. This is the like hello world project on JavaScript. Okay, let's go next. So now let's open ABI file and see how it connects with our message creation. Let's open. So here's ABI file. It's actually the interface of the contract. You can see the methods of the contract, and let's go to, for example, to the get method timestamp, get timestamp. Yeah, you can see in code message, we provide ABI address of the already deployed contract, and we define function name timestamp. And we do not sign this message because this contract do not require any signing, any keys. So we create this message and then we execute this run TVM. We also provide ABI here because we need to decode the result with this ABI. It uses these values to decode, and then we receive the result in this decode output field. So this is just for you to understand how ABI and message creation are interconnected. Okay, let's go next. Yeah, to get further understanding of SDK most common use cases, go to the documentation. Here you can see these common use cases with contracts. For example, how to, in more details, how to add your contract to your application, how to deploy contract, run contract. About external signing, I talked about how to connect with some external devices for signing. Also, you can read about message delivery here, which I mentioned before, that there are some situations where messages are not delivered. To understand how to resolve these issues, go and read these articles. Yeah, so there is a lot of information actually. Okay, so what's next? Now I think it's time for us to explore GraphQL API. Documentation is here, and we will check out the API of our local node and then some mainnet or devnet API. So what is GraphQL API? GraphQL API is actually the blockchain API SDK works on. It allows to query data from blockchain, parsed data, and send messages to blockchain, which are created on the client side, and subscribe to blockchain data updates and contract events. So go to this samples section, and here you can see the samples most used and samples that were asked by community. For example, let's go to mainnet and get our blockchain config. Okay, so to understand actually what is going on here, again, you need to read specs. But in few words, I just got the config of the blockchain of the current at the current moment, so I can see the information about elections here. I can see the current validator set here. You can see these validators with their public keys and DNL addresses. And here are some other config values like maximum number of validators, minimum number of validators, min stake, max stake, and so on, and timing for elections and so on. It's just one example. So you can go through all of these samples. And to get, after you read the specs, you will get better understanding of the blockchain. What actually is this config? What are these shards and so on? Yes, so let's go and see the results of our execution of our Hello application on the local node. Here you see, you can find the step here. I added this queries here. You can use them to run on your computer. So, for example, here's the query of the account that I deployed. Here's its ID, workchain, last transaction, logical time. Again, read specs about this parameter. Balance, block encoded in base 64, and code hash and data. There are also other fields. You can check the API, you can check the data scheme of the GraphQL API here. Click Docs button, and you will get this self-documented schema. You can see some definitions here. So it's basically self-documented. You can go and just look at all the fields of the account, of transaction, like total fees and incoming message ID, fields of blocks. So Masterchain block, for example, has a master field, and Shardchain blocks have master field empty. What else? You can check info query, which will give you the version of the GraphQL server running at the moment. You can also get some aggregations here. You can count number of blocks, filtering them by some condition. Or here you can see all the possible filtering options here. And aggregate other things like, I don't know, number of transaction of account, or number of messages, or number of messages between some accounts, and so on. All of these samples you can find in the samples documentation. Okay, so here let's go to the transactions that were generated during our execution of Hello project. Here you can see 3 transactions to this address. So here you can see messages. This is the deploy message, actually one, big one with provided block of the contract for deploy and data. So, okay, so what's next? We read about local node documentation. Oops. It's here. I also left some link there. So here you can find the installation guide. If you have some problems, go and read here. Also, here's information about giver, its ABI, its address, and its Solidity code even. Also, please take a moment to read about differences in behavior of local node comparing with real blockchain. It has some differences that are very important to understand. For example, it doesn't have any master chain now. It doesn't generate empty blocks and stuff like that. So the next thing you should do for further exploration of SDK is to check API reference. At the moment, our API reference is situated here in our core SDK repository. Here you can see a description of all modules, functions, and you can go to some function, for example, in code message, and see the parameters description and the function description, then parameter descriptions, and some parameter types descriptions as well. And these code snippets of function signatures in TypeScript and type signatures in TypeScript. The last thing I want to talk about is architecture of SDK. You can go to our core repository Ton SDK and read about it in README. But basically, in 3 words, we wrote our core library in Rust and created thing bindings over it in TypeScript. And also community created several bindings in other languages. You can also find it here, find them here. It's like 14 languages overall. PHP, Python, Swift, and .NET. So you can even create your own binding if you want in your language. There are instructions how to do that. There are instructions of the JSON interface that is used to connect thing binding with this core library. So a lot of information. If you're interested, just go to the Ton SDK repository. And this small thing I added in the end is just, I don't know, for overall understanding, you can go to this file and read about smart contract addresses formats, that raw format exists, and some bounceable, non-bounceable addresses, but it's not the most important thing to read, but it's pretty useful. And also you can get this overview of account structure here. Maybe it will also help you to understand what is bag of sales is and of account, and make it easier for you to understand the message creation in SDK. So I think this is all I wanted to say. I hope the link to this guide will be provided somewhere below the record of this call. So thank you. If you have any questions, please ask, or you can also join our Telegram channel. You can find the link here. So there's a lot, like to 100 developers there, and you can get any help very quickly in that channel. Okay, so thank you. I think I will stop my sharing and yeah.
Thank you, Katya.
Thank you.
Boris?
Hi there. Thank you, Katya, for a great overview of how Ton blockchain can be used. I was going to how smart contracts are created, how they're designed, what are the rules, but instead I decided to show you how it's done. So in a few words, smart contracts are the programs which work on blockchain and have persistent data. That's basically all the theory about smart contracts. The rest are related to implementation. So there are pages for the developers which describe basic process. You can write in Solidity, you can write in C++, but the main aspect is that you should know how blockchain works well to code for it. There are samples, many contracts, so wallets, casinos, banks, piggy banks, etc. There are contracts which work for the community. For example, let's see, that's governance page, which hosts all the contests which are held for free time. You see, there's a lot of them. So starting from this and all the way up, all the contests are held served by a special smart contract, which accounts for all the submissions, all the jury's work, evaluating and storing their comments on blockchain. That's the only known to me real contest held on blockchain, not just storing data, but taking care of all the process. The contract which facilitates this is open source. So you can see it. It's not really that big, but it actually takes care for all the stages of the contest. So it must be very complex and really difficult to work with this contract, right? Well, not really. Let's take a look at how it's done. Okay, we have a source code editor. There is how the smart contract code looks like. You see that's the same code. So we can compile it using some scripts. So it compiles the code of the contract and then puts the code into the data of another smart contract, which serves as a on-chain deployer, which helps to set up the contest, set a set of juries who will be working on it. And so basically what do we do here? We compile the code, link it into the binary form, which doesn't look really understandable, but that's how it looks. Then deploy this contract on the blockchain, and then we can watch it on the web in the same Ton.live as you had seen before, right? There is a contract, there is its code, its data, which is basically the code of another contract, which you have just loaded into it. And that's combined code and data. You can see messages you have sent to the contract, setting a jury. So let's set up a jury for it. Basically, it takes a fake set of keys and set of addresses and pretends it is a real jury to help test the contract. Okay, we have set of juries, case and addresses, and then we simulate a creation of new contest with the parameters we have set, right? Setting its title, link to the forum, hash, start date, end date, etc., rewards, number of juries. Is it the same data? It's actually why it's taking so long. It loads all the data in the blockchain for us to view. So later we can check if there is a data. See, there is a data which we have just deployed, right? That's the code, that's the versions, that's set of juries. And encoded are also the numerical parameters for the contest to deploy. So, okay. That's the contest we have deployed in the blockchain. So another contract, right? It's the contest itself. We can check if it has deployed successfully. Basically, it tells everything about itself. Information, set of juries, which are read from that contest already. Timeline, when it starts, when it ends, when voting starts, stages of the contest, rewards, which are due to the participants at the end of the contest, and the information about the current stage of the contest. Basically, this is a simulation of the same process which is used to govern all the Triton contests, and that's how tokens currently are distributed to the community. And basically, that's as simple to deploy rather complex, useful, and real production contract. So it's great to develop on Triton as a platform because it offers you unique debugging capabilities. You can check every transaction, every message, and you can check all the information about it. Why it succeeded? For example, you see that aborted is true. There is a reason, and that's guess limit, guess used. Okay, we are in the limit. Exit code is 51, and I know that the constructor was already called. That's all right because we have deployed tried to deploy the same contract on the same address, which is basically harmless. And that's how we can oversee all the operations of this contract, and we can always pinpoint all the divergences from the way we wanted it to behave. And that makes programming on blockchain also very much fun and very rewarding and satisfying. So basically that's it in a nutshell. That's how smart contracts work on Triton. It's very, very different from how other blockchain works. So if you have any previous blockchain knowledge about Ethereum or other blockchains, you'd better start anew. And all I can see is that writing smart contracts for Triton is like, for me, it's a great hobby. I do it just for fun. So if you have any questions, please direct it to me. I will be happy to answer.
Thank you, Boris.
I think the team is overwhelmed with the amount of information. But let's give it another minute to ask some questions, potentially. Mr. Mutemi, how about you talking about your experience with Triton? I know you're doing a couple of applications. Do you mind sharing like a little bit your experience and maybe some tips for the other folks?
Okay. Hello. Hello. You can hear me?
Yep. Yep.
Oh, okay. So maybe I can share my experience so far with Triton as you propose. And yes, I am doing a few projects under Freeton. It would be one for a financial project and also a storage solution we are looking to implement in a sector which currently faces challenges in terms of how information is stored. This being the farming sector here has quite a few challenges we are looking to address. So you guys can see the PDF I'm sharing, correct?
Yes.
Okay, yeah, so my name is Thomas Mutemi. I am a Kenyan, I live in Kenya, Africa. I've been doing software development for, I think, 11 years now, and that's my company's name. So I came into Freeton through John. I think he's a very active member of the SG, and through him, I actually got into it. Been trying to find my way around, and maybe I can talk about my experience in terms of how difficult it was for me to get in, what I had to understood, what I had to put aside, and the new things I had to learn. So at least I could, develop in Freeton and also be able to implement solutions in it. So I think the most important thing for anyone to understand, and any dev who's coming in here, especially from the African continent, I do understand that in school, we are not necessarily taught anything to do with blockchain. We are just taught all forms of classical computing, from our relationship, the sort of databases, to how we do our solution implementation, to websites, to apps, all that type of stuff. But when you come to blockchain, things are a bit different. And I found out that the best way for me to actually acclimatize to that kind of situation, whereby now I'm doing something different in a different way, I haven't learned it, was to try and get comfortable with, of course, the new experience, accept its different aspects and all that. So first thing I went to there's a dev platform you guys offer. I went to it, had a look, and actually tried to set up a few of the items, both in VirtualBox, as you can see here. And also I tried to set a majority of the test environments that you have in Postman, which I use a lot, so that I could at least know what to translate, which features to translate to my projects and all that. So the first thing I would encourage anyone to do, of course, is to, you have to know what you want to do. You have to understand it in a very, very native nature, and understand that the documentation provided by the Freeton community does not give use case examples. For example, some of you might be here wanting to do a financial project. You have to understand it is very unlikely you'll be shown, go here to put money and all that. Those examples do not exist. You actually have to understand the whole thing. And by this, I mean that the documentation provided is very, very native. So you need to know what your input process is like. For example, if you're transacting in tons, you need to understand how to query the ton balance on the GraphQL. You need to set up the examples very, very well on where you are most comfortable and where you can actually translate that to actual code. You also need to understand the process. This is something every developer is actually clear on, and the output that you want to do. Like I can give you a very, very likely example. Some of us want to make applications which allow people to buy and sell tons in their country and all that sort of stuff. You have to understand that where to go in the documentation and all that kind of stuff. So I would also encourage some of us to, set up the CLI as I've done here, have a look at it, because even the examples provided, the feedback, we are all just, going through here. So maybe if I can speak on a more direct note, you can set up your script so that they are just able to send commands to your command prompt. You get the feedback and would do all that sort of stuff. You can process the information from there. You can also do the same with Postman. I'll also share this collection on I saw we have a Discord. Maybe this will help you. It's a very, very popular tool. And you can see how you can translate this to your program. I understand that most of us have that challenge whereby, okay, the devs have shown us what the blockchain is about. You've learned all about contracts, but you want to do X and Y. You don't necessarily know where to start. It's always a good step. You can use your favorite programming language, set up the URL, set up the JSON body and get the feedback, and maybe translate this to a way in which your users can be able to see, okay, this was my last transaction. This was the cost of gas, and, translate that to the local currency. So at least they can have a better understanding of what you're trying to do. And I think a big part of the projects some of us are undertaking is actually trying to make, blockchain much more visible to the general public. And even some of our projects are very, very public. So that would be my advice. You should also know that the community is actually very, very willing, because I believe when I started, I talked to Ekaterina on Telegram. She gave me a few instructions, and from what she told me, I was actually able to find my way around. I knew where to go in the documentation. I knew the GitHub examples I had to install on my virtual machines. And then from there, I can translate that to actual projects. So rounding it down, my advice would be know what you want to do. Ask, at least get your bearings. Don't be afraid. Don't be afraid, to even show your naive side that you don't know X and Y. But trust me, you'll be able to get there once you are very, very comfortable. So do not be intimidated by anything. That would be my advice. And that is my experience. So yeah, I don't know if there's any question. The rest of the presentation that I had, I think the last presenter covered it so well. They actually showed active examples of what I wanted to show. So I don't want to repeat that. Yeah. Any question?
Great. Thank you very much. Amazing.
Yeah. Oh, there are no questions. Okay.
I think everybody is just overwhelmed with the amount of information. Mr. Kayode? Yeah.
So somebody asked that question that I just typed inside the chat box. They asked that did not get the content for the tools and development environment setup. I don't know if Alex, you have something to say on that.
Who wants to take that question? Because I unfortunately have to jump on another call in a few seconds. So I'm sure Kayode, somebody would answer. Just wanted to thank you again for inviting our team, and looking forward to the outcome of your great hackathon.
Yes, no problem. So, all right, thank you very much again. I think it has been a very wonderful time we've had so far on this first day of the workshop. And good news that we now have full knowledge combined with what we've done yesterday. And now I'm sure right now we have full knowledge of the blockchain technology, and now more importantly, the free Ton blockchain platform. So just remind us, the hackathon starts fully by tomorrow, by midnight, 12 a.m. midnight to Friday, 11:59 midnight. So I will encourage us to be active. The tags will be dropped there on the Discord channel. I will encourage us to go there and start looking to it. The recordings and the links of this program also will be shared on our resource platform as well on the Discord channel. And after now, there's a internal program on the Free Ton network that also like a continuity of this program that we're having is going on right now, very soon on the YouTube, which is what Ron sent on the chat box, so you can see it, but same as well, I will copy it and send to us all on the Discord channel. So guys, just be aware, the hackathon starts tomorrow. I want us to make sure we keep tabs on the Discord channel. The same people that spoke here today, all of us are on the Discord channel. So you can easily reach out to us on whatever it is you are bidding, and we'll be able to prefer answer to you, as well as the developers community also on the Telegram group as well. So guys, thank you very much again for your time, and look for the links on the Discord group, and I look forward to engage with you moving forward on our Discord channel. Thank you very much, guys, and have a very good day.
Thanks.
Thank you, Kayode, and everyone.
Yes, thank you, Katrina. Thank you, John.